YouTubers are regaled with no audio. Oop, oh, I'm hiccuping. Burp. I had a really crappy hoagie from the supermarket today for lunch. Very heavy. hopefully it cooperates. All right, this thing is good for now. We're good for now with this thing, right? It kind of scrapes a little bit there. Probably needs a smaller wheel, but my makeshift turntable, I guess, works well enough that in the future I may be able to use it to get good scans, but we're not worried about that right now. We're actually going to work on some of this test gear that I got in the mail, not in the mail. Not in the mail. I had to go pick it up at a friend's house. A friend had a bunch of stuff from the Drexel University labs that ended up in the garbage pile, so we got to see if this stuff is good. It'd be pretty cool though. Got a lot of good stuff going on. Let's get this, like, I need a clear desk. Oh, my light didn't work. What the heck? I thought you was a Node Red Flow. Thought you was gonna work when I started the stream. We had promising things going on. Maybe I don't need the Java-ification. What's this thing? This thing is just a turntable. It's a machining turntable. So it's actually meant for, you know, taking tough loads, like most of us. But no, it's for taking, you know, heavy stuff and moving it circularly under the milling machine. But instead, we hooked it up to a little gear motor that I have and had it spin stuff so that we could 3D scan it and get a reliable 3D scan. And it turns out to be pretty good. Turns out it did pretty good. So we'll be coming back to this. Oh, for now I'm just gonna put it over here. It's so heavy. Okay, so heavy and off kilter. Yeah, homemade heavy duty turntable, but it doesn't turn heavy doodly. It the belt slips on the little turning handle. Is there something wrong with my Discord, or is the invite link not up to date? First time I've seen the bench uncluttered. It's about to get less clutter than that, believe it or not. I know, I actually need to clean it off and put the new desk protector down. I'll have to look into the Discord invite. It should work. I don't know if we've had people join the Discord lately. I can generate another one and update the comm, I guess. Let me generate an invite. Let's see. Where do I go for that? Announcement stuff. Right click. Copy link. Invite people. Send a server invite link to a friend. Why did they hide it? Why would you hide it? I hit copy and it said hidden use copy button. It said the invite link. What's up, Red Dog? It said the invite link. This is the announcements channel. And I went and I right clicked and I said invite people. And then it says hidden use copy button. So I hit the copy button. And then I close that and I go here and I go paste. And it says hidden use copy button. What? Wait, what the fuck? What are you talking about? What the hell? Who made this program? Your invite link expires in 7 days. Expire after never. Max number of uses, no limit. Generate a new link. But it doesn't show me the link. Where's the link? Where's the link? It's hidden use copy button, and that's all it. Yeah, I guess I gotta go into the server settings. So, all right, let's go into the settings here. I'm gonna not have the camera up on screen. No, that's my personal settings. I need to go to the server settings. Security actions, create channel, create category. Sorry, server settings. Overview, emoji, sticker, soundboard, widget, server template, custom invite link. Here we go. Streamer mode's enabled. Oh, that's why. So let's turn off streamer mode. Custom invite link. Make your easily accessible fancy custom invite link of your choosing. Be aware. Unlock with boosting. Oh no, I can't. No, close. We don't have enough boost to do a custom one. Okay, well, can I just get the regular one, please? Okay, there's the regular one. Let's see if this one's any different from the one in the command. SEHQW. Yeah, this one's a different code. All right, so let's just update that com. Let me go now to admin channel where we do things like that. And I do Discord. And then paste that, copy this one. Go over here. Hold on, I'm doctoring right now. Edit com. Okay, so Discord com has been updated. Now I got to go into Nightbot. Nightbot. I always Google Nightbot because I'm dumb. Or for some reason I don't know the URL. I don't want to learn more. I want to get into my account. I don't want to add it to my chat. I just want to log into it. Oh, here we go. I'm in. Commands. And then, wait, that's commands. But what about? Hold on a sec. Discord I just updated. That one should be okay. Still have a lot of commands. Let's see. Where was it was sort of like the frequent chat message, right? We had way too many commands. I had to get rid of a lot of them. You still have a lot. I need to do another one of these little purges. I don't know. Is it stored as a command? It was something about Discord says something is going on with my account. Oh, okay. Well, we've got a new link now just in case. It's just good to refresh these things every now and then. Oh, here's the Discord one. We'll just edit that and I'll put in the new link right there. Oops, I just hit copy on it. Hold on a minute. I gotta copy the new one. Oh, this is a disaster. All right, there we go. New Discord update. Hopefully that doesn't push the text into a weird space. No, it doesn't. Okay, the bars are still above and below the text if you have a standard width. All right, so whatever. I haven't visited Nightbot in a little while, so it's good to check up on that. But apparently the fault was not with me. An error occurred. Please try again later. Wait, what? What's going on, YouTube? What are you doing? YouTube all right? Is it doing okay? Connect streaming software to go live. Oh, there we go. Okay, I see it now. Sorry, no movement on screen for a little while, just because I'm trying to figure out all my stuff. This thing didn't work either. I got to look at this thing now. But yeah, this is the old equipment that we're going to take a look at. I'm going to fix the camera on this stuff. For a bit. For just a bit. Just a biznit. Mic cable's caught in everything. Power supply stuff goes over there. Let's see. Nice calculators. Yeah. What up? How's everybody doing? The light bulb. What happened with that? I gotta go into Node Red. See what happened there. It's powered on. It's powered on. Let me open up Node real quick. There's a lot of windows on this computer right now. A lot of windows. All right, so the light still works. Yeah. These are my not portable calculators. All right, so I tried this, and the light turns on just fine on my desk. You guys can't see it. Maybe if I put it, well, if I hold it like this, I can hit it. That works. Turns on and off. So something's wrong with Node. Do I have a Node window open somewhere around here? Does the rack not have wheels on it? The one over there does, but these aren't going in that rack. They're way too big for that. That is a miniature. The rack that I have does not have the depth for that sort of thing. This is like a communication. It's like a studio rack. It's not like a big telecom rack. So no on this one, no on this one, no on this one. I still have to Tasmotize those other what do you call it? The other light bulbs. I haven't gotten around to them yet. Need to make one so that I can use the REST API in order to get into the server. All right, so I just don't have a Node Red open right now, so let's open it up. We don't need JLC. We're waiting for boards in the mail. We're going to see if we like JLC or not. Put on Node. That'll be the one. So down here, I have my OBS status. That's for the status light. And I guess that one goes into JSON. Does it still work? Yes, it does. The light just turned on. You can see it turn off right there. So that one does, in fact, get the JSONification of this thing. Down here, we have connection status. Contains closed to turn it off. Get stream status. Turn it into JSON. Or if stream status is changed. Contains started or stopped. Red, green, orange, etc., etc. So if I inject this by toggling here, nothing happened. Okay? So what are we looking at? We're looking at JSON. Message payload contains, and we're not looking at it in JSON. Maybe we can just get rid of this. And instead, I can take this to here and this to here. I think that that's probably what Leb was trying to tell me the other day too, that this stuff is updated and it doesn't need the JSONification of the thing. Although here, it's looking for require param FPS is true or not. That's a different one. This is the contains spring arm message.payload, but that still works. Let's just deploy this and try it. Output active true, output bytes blah blah blah. Output required connect. And it doesn't contain start or stopped. Huh. Let's get stream status. What is the JSON doing? It's packaging the strings that are returned into JSON so that message.payload has stuff in it, I guess. Those calculators look like they have a fancy temperature compensated voltage reference inside. You know that just by looking at them? I don't know about that. I mean, yeah, some of them probably do. Weird. Okay, so I know that this stuff works. I know that contains started or stopped does work. I know that if I look at the stream status changed in the debug, you can actually see, and I'll just add it to the same debug and deploy that, even though we're not going to get anything from it because the stream status isn't going to change because I'm not starting or stopping stream. but I do know that it contains that. Do I see, what is that, TM5000? You would know better than I would, but yeah, this is the equipment that we had at Drexel University 20 years ago. Yes, they are TM5000 and what is that, 6? all old Tektronix stuff. Pretty cool. What is this, flow programming? This is a Node Red, and it's what I use to automate some of the lighting in the shop. And I'm trying to make a couple of these things, a couple of these little guys right here, these little Tasmotized lights, be my on-air lights and my, you know, general just studio stuff. Oh, the end of the number is how many slots it has. I see. I see. I don't know what use I'm going to have for the rack itself. I know the test equipment might have some use, but we're going to see, because this stuff has sat in a shed for 20 years, and we have to evict any residents that have taken up space in sort of the interstitial areas of this. We also have another device that I want to take a look at the very beginning. I have this thing to look at. We got to take apart this thing right here. This thing. I want to see what it's monitoring on my power lines. I didn't plug this thing in when we got the generator because, you know, fuck you. You're not going to take a look at my power. I'm not going to let another internet-enabled device phone home about the power systems in my house. So get stream status does not tell the state of the stream. State of the stream has 4 different parameters. I don't know how to invoke it. I mean, is there a way that I can get state? Request get stream status. Get stream state would be what I'm looking for. There's a lot of very dangerous controls on this thing. Send stream caption, get transaction kind list, get current scene transition, studio mode, bar position. This is like crazy. Open input properties dialog, monitor list. No. Stream caption. See, I can have chat activate stuff through these too. They can activate things in scenes and stuff. Pretty powerful. I mean, to get any more powerful than what I've got here, I would have to use something like Lorraine board or some of those tools that Gonad uses to get really crazy. Post stream key in chat. I practically expect it to be right here. Yeah, give stream to chat. So source screenshot active, transition mode. I need the get current preview scene, program scene, get group list, get scene list, get scene item blend mode. What the hell? Get scene item index. This is so low level. Duplicate, remove scene item, delete stream, and go live on a farm is one of the options here, apparently. New streaming channel, the real oh bother. Just like I'll pull a Ghostbusters. Get scene item source, scene ID, get group scene item list. Oh my god. You could make your own OBS like interface with this. Get jaunty hat. I don't have a jaunty hat available. It's one of the jaunty things that I don't have available. I have silly sunglasses all over the place. Toggle record pause. Get record status. Get output settings. Output status, output list. Toggle replay buffer. Get replay buffer status. Come on, there's got to be. Get virtual cam. Trigger median input action. What the hell? Get properties list. It's basically get stream state is what I'm really looking for. Input mute, set input mute. Get input settings close, but not quite. Nice hat. Just imagine, these are just the requests. There's some really crazy stuff in here. Basically get all of my settings. Trigger hotkey sequence. Hotkey list. I can turn this all over to some kind of a stream elements thing, and you guys could spend real money to control my stream. I'm not going to do that. Request sleep. Streamer, you need to go to bed. Get source filter default settings. What the fuck? Record directory. Oh my god, you guys could ruin my computer. Video settings, profile parameter. This is profile stuff. Create scene collection. Set current scene collection, set scene collection list, persistent data, and get persistent data. I don't see anything pertaining to stream status, as in like the broadcast status. You know, you can start and stop my stream. I can't believe that there's not... Get stream status gives you output active true, but not... I mean, I guess I can also do... I can add one that would be... just contains true. And then set that one to be red. And maybe if I deploy that, and then I go inject the stream status, it didn't turn on. What the heck? Grab another debug node over here and see if that one's outputting at all. Okay, so it's not actually message payload. Message payload is an object, and it looks like it is not a... Well, no, it contains... I've been summoned. Oh no, my ineptitude with I mentioned that Leb was trying to tell me about doing this. I got rid of the JSONification of this, but it's not really working. And also, I don't have in the OBS thing, I have stream state changed, which gives the state of the stream, and get stream status. I can't get stream state. So I can't like inject a get into this and get it to trigger. So I have this manual one over here that's request get stream status. And request get stream status gives me an object that gives me the output active is equal to true, right? Or output active is true in JSON. It's not a string object. So I'm not JSONifying it. So if I have contains, message.payload contains true as a parameter, can you parse the JSON? Do I need to put one of these guys in there then? You need to set the change node, similar to my example I sent you last time. On the top, you need to have the property set to message payload output active. So message payload and then output active on this one. So like this. If I'm doing this correctly, I may not be. Did a quick Google and it gave me a webhook that looked something like, yeah, the typical one, the stream status changed, this one here. This one here outputs that parameter, and that's what I have this looking for. OBS WebSocket outputs started and stopped are the main ones. So there's also the transitional ones, starting and stopping. But yeah, I've got all those in there, right? I recorded those last time. This is what the output was. Where's my... Oh, did I close? I closed Notepad++. Darn it! Well, I had all the commands in Notepad++. Without the JSON node converts it to a string, and then the contain works like you have it now. I see. So I do need this, and it needs to be message payload output active. Then presumably, if I toggle, the light doesn't turn on. Darn it. I'm still off. I still don't know what I'm doing. Oh, is it still up in Notepad++? Or did I lose? I think I might have lost. Oh no, we still have it. So this is what I get from the other node. Output active, true or false, output state, OBS WebSocket output starting. And this is it stringified because it's in quotes. Stream status, message payload string, and then I looked for OBS WebSocket output stopping. Guess it's as good as mine. I've never dealt with Node-RED. It's not too bad. You kind of start to get it after a little while, but I of course have a bunch of trouble with it. I mean, it's going to be looking in this whole string, right? This whole string. And if it finds true or false, or OBS WebSocket output stopping and starting, I'm just trying to get it so that when I toggle it, I get the light turning on and off. But it doesn't appear to be working. Too much point and click access API directly, take info, manipulate as needed. I'm one for that sort of programming, but at the same time, this works. This works too. I mean, it should still be working from what I see here, because the message output, and then if I take it from the other side of the stringifier, let's just see what that looks like. I mean, I guess if I look for the whole thing, output equals active, yeah, something like that. I don't know. Hold on. Deploy this. Basically, with the JSON node, message.payload after the JSON node is a string, like you have it in Notepad now. Then it just searches for what you set in contains inside that whole string. And it should contain that. It should contain a true or a false. It should contain a giant thing that I put in. Do I have to put it in quotes, though? Maybe that's part of the parameters. So here I get quote, output active true, output bytes 13, output congestion 0, output operation, blah, 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 right? That does not work if you have multiple true false in the same string, as you could totally be looking for any other property inside there. If it receives multiple, wouldn't it trigger multiple times? Maybe it doesn't do that. Although there is only one. Oh no, there's true and a false. From the OBS node, an entirely new change node after that. What do I have to... Wait, what am I changing then? Oh, what just happened? Cheesy Popcorn. Hey, Cheesy Popcorn, thank you for subbing. Appreciate that. Oh, and then, 5 days ago for the other one. Jeez, I haven't streamed in a little bit. There's some real life stuff that kind of got in the way. Thank you for the Prime for 5 months. I really appreciate those Primes. You know, those don't give you a reminder. So from the OBS node, add an entirely new change node after that. Then in the change node, set the property on top to message payload output active and create 2 entries with is true and is false. So you're trying to get something like, something like up here. So if I do get stream status as a different flow, we'll just make that a new one. We'll add a toggle to it. So this is a new instance, get stream status, and then I've got my outputs here. These are errors if it runs into errors, so we'll not worry about that right now. So you want a change node to JSON, if I'm correct, but you're saying a new one. No JSON node, just a change node. Which one is that? That's one of these guys, maybe? No, hold on. Change node. Change right here. Change node. And we're setting message payload output. and then I want active. Oh, output active is one word. Hold on. Message payload output active. It's a switch. We're switching. Message payload output active. And we're adding 2 in here equals true and false. This is very similar to what I was doing with the other one. I don't know why the other one I didn't work. True, false. And if it's true, true, or if it's false, false, I'm going to steal some of this stuff. It's weird, though, because I had this working before. I mean, my little injections worked just fine. False, green, true, red. Don't need these. Orange and yellow. And then off is for a different thing, but I'll get rid of it here. And so presumably, this is going to turn it on. Oh, there's is true and is false in the dropdown. True, false. There we go. Need to make for this a light for this too, and for internet connected. Yeah, that's eventual goals, and also with burn the subs, I'm gonna have to do flows like this as well. Have you considered getting one of those push button lights? The whole point of this is to tell me that my stream is live, and so I know to hit the stop button when I'm done streaming. Well, shit, that didn't do nothing. That didn't do nothing. Let's get our debug over here. See if we get anything from this injection. Output active true, output bytes blah blah blah. So this did get a flow. But then this one switched message payload to power on dimmer color 40 red blah blah blah. So that should have turned on bulb 1, and it did not. But if this got the flow, we should be seeing it there. Power on dimmer 40 color red. Server bulb 1, single output Kelvin channels. So something is, you know what? These flows might have been okay. This stuff might have worked. It's the bulb that we have identified as not working. That thing ain't turning on. Wait, it is on. Wait a minute. Hold on. Wait a second. That did work. Okay, never mind. I just didn't notice it because it looks white on the camera. So when I get an is false, that should turn red. So I need OBS WebSocket output started, OBS WebSocket output stopped, etc. Oh, where does that go? So if we're coming out of here, and here we're looking at payload output active, instead we would looking at payload without turning it into a string. It would be output state, payload dot output state. So we don't need to just sonify it. If I'm looking at payload output state, and it still contains or is equal to, it should only contain that, but output started, output stopped, etc. And then that will change this stuff. And this one doesn't work anymore. Whoa. because this one isn't valid anymore, because this is looking at the specific stream state changed property that doesn't exist inside the JSON of the messages that get stream status provides. So this is just an override button in case I wanted to do something. This should work normally. And then if OBS connection status, if I close OBS, it'll turn off the light altogether. Contains and equals should be the same in this case. Yes, that's what okay, good. As long as I'm firing on the right cylinders to get this thing to work properly. Let me bring in another bulb here just to clean that up a little bit. Don't cross-contaminate all my flows. So this is my auto off. This should auto turn it off if I close OBS. And then if I need to, I can toggle it from Node-RED. Then I've got, well, this is just to test the color formatting. Then I've got, if the stream status changes, try to line these up a little bit. If the stream status changes, this should look very specifically at that status change message and then give me a red, a green, an orange, or a yellow. The whole point is red means stream is active, orange and yellow are transitional colors, and green means, yes, you've stopped stream and everything's fine. If I close OBS, the light turns off, which is fine. I rarely close OBS. The OBS instance in this case has been on for like 4 days, 5, 6, 7, 8 days. Oh my God. But I'll probably close it after this session. It's just every time I do that, I have to recalibrate all my cameras, and it's annoying. So I could automate the full calibration of the cameras with Node-RED. I just haven't gotten around to it. Plus, I also kind of don't trust it because sometimes Stream Deck messes up in its own little ways. Let me get this moved over. I need to move it to the right. Guess I got to do it in this sequence here. Boom, boom. There we go. All right, semi-neat. I could probably put boxes around stuff in order to try to make it all look a little bit more managed. And then the only way that I have to test this one is to actually just stop stream. I guess I could probably put in a toggle that would inject message payload as the thing that I'm looking for. So it actually, the message payload is equal to, let's make it starting. Message payload, string 68. We'd have to unstring this actually. Or I could make it do that, but whatever. Bottom right zoom button. Oh, okay. Well, I'll keep in mind this right here. I use control zoom instead of this. I should get used to that. All right, well, I can't do anything about that. I got to wait until stream stops today in order to run that. So my red light is going to continue to be red. I'm going to deploy this, make sure it's deployed and ready to go. I'll keep the debug over here, and we'll just see if anything. Let me just clear it. And when I stop stream, I'll get to see whether or not I actually got a positive hit on this. Error handling, there is none right now. That's neat. You can drag and then let go. And it's like, hey, what node do you want to put in there? That's cool. Boom, boom, boom. Cool. All right. Well, that's a little bit of Node-RED for today. I want to take apart this thing. This thing right here. I want to see what kind of electronics this thing is putting on the putting on my power line. Because the folks who installed, the good folks that installed the generator in this house, gave us this thing to plug into the wall so that they could know if there's any electrical faults. And I'm like, hell no. I'm not going to give you guys that data. The Ting Incorporated is selling people's power statuses. I want to figure out what this thing can know about my power lines. So let's get the music out of here and we'll just start stream. We'll just start, you know, quote unquote early. It's not really early. It's not, you know, it's kind of like start kind of late anyway. Wait, I've got a notification YouTube. Need some advice. I got a SafePal wallet. What the fuck? I hate that shit. Wow, that's such a great, I'm going to leave a comment on your stream. Wow, such a great stream. I'm going to advertise my crypto on this. It's like, dude, nobody watches my YouTube videos. Come on. I had one plugged in right now. I know it's it knows I consume a shitload of energy. How do it know? How does it, it's like a thermos. How does it know to keep hot things hot and cold things cold? It's an amazing feat of memory. All right, so I'm going to fade out the music. This actual fade out, believe it or not. We can afford that sort of thing around here. Hi, how's everybody doing? I know I haven't streamed a lot lately. There's a no start soon on here. I forgot I always forget something, and it might as well just be that. The little overlay that says that I'm not actually streaming right now. It knows I'm curious to see what's inside your device. Yeah, I would like to know as well. So we're having just like a generic day of random stuff. The random stuff is mostly going to revolve around this stuff here, this 20-year-old. I actually don't have a date. We'll have to take a look at some of this stuff to get like a date for when these things are actually, you know, what era of electronics is this relevant under? Is this TTL logic? Is this, who knows? We'll figure it out though. We'll take some of this stuff apart and see if it more than 20 years old. I want to figure out if it's probably late 90s. Let's be honest. It just puts us in the 30-year range. But anyway, so we've got all that stuff, and then I also have this thing from the people who installed my generator. They wanted us to plug this thing in so that they would know if we needed extra electrical work done. The answer was probably going to be yes, no matter what we did, but this looks like a pretty sealed device, and I just want to figure out what the ins and outs of it are. So we'll do a little bit of test and measurement equipment, and then do a little bit of this test and measurement equipment. The problem with this thing is that there is no feasible way to take it apart, and it doesn't look like it's plastic welded. I can see a very dark seam. The seam would be a little lighter if it was welded, so I think it's maybe just snapped together. I haven't looked at this thing previously. This thing came up when we were cleaning up. We were cleaning out some stuff, and I was like, wait, what is this thing? And I'm like, oh, I remember this. So there's no screws behind the label. You push down on the label and see. Yeah, it'll text them if there's a power surge. It does more than that. It does more than that. Designed by Whisker Labs in Maryland. Oh, that's nearby. Huh. Looks like the old equipment on a hydraulic testing machine we had at my college back in the 2000s. Well, believe it or not, that's the rack equipment that we had in my college back in the 2000s. It's just they decided to clean out the labs and get rid of all the old crap. And that includes all of these really nice Tektronix things. TM5006, first print 1981, revised in 1987. What the Holy shit. So it's mid-80s stuff? So there's got to be a way inside of this thing. Now, this is electrical equipment, like plug into the wall electrical equipment. So it stands to reason that they make it very difficult to get inside of this thing. I want to know what electronics are powering it, and I want to know what it's looking at on my power line, what it's capable of seeing. What have you seen? What do you know? I doubt there will be ASICs that are specific to the application. I have a feeling it's just going to be something that can look at like the AC power. 40 years old. Oh no. How do I get into this thing? Damn. Come on, buddy. Give me something I can work with. Like a big old screw hole right here would be just fantastic. But that doesn't appear to be the case. This label has all of its like FCC information and the MAC address and stuff. I'm not interested in that because this thing will never get powered up because this is a monitoring device. I don't trust these things. AC device, here come the sparks. No, you mistake me for somebody who would power something like this up. Well, in this case, it's a hammer or a vise. A vise, I think, is a much more civilized way to open it up because you can deform the plastic right to the point where it breaks and then you can stop. Whereas a hammer is putting a whole bunch of force on it uncontrollably. You may do light, gentle taps with a hammer, but it's still, in this sense, you're giving it all of that percussive correction that it shouldn't really endure. So the problem with my doing this is the harder that I press in from the side, this will slip and puncture my hand. So I've just got to be careful about where the force is going that I'm applying. And there it is. I'm into the seam. Let me just give it a little bit of excess of force, and it looks like I broke something already. I pushed up one of the little veins here, but I'm actually putting my thumb on the line here by putting it between the layers of plastic. There we go. That didn't give me too much issue. There's the antenna. Oh, here's a nice little Wi-Fi antenna. They actually bothered to put a separated, not RPSMA, but it's RP, whatever this thing is, antenna on this. This is fairly complicated. All right, so I'm undoing the antenna here. I could save this for some other application. There's even double-sided tape on it that hasn't been used. Hey, look at that. They didn't even peel that off. That's clever. So this is something that I could definitely put into another device. So keeping that, kind of like this one that I have sitting right here too. Another inverted planar f 2.4 gigahertz adhesive antenna. I've got a collection of these things. Lazy assemblers. That's not lazy. They didn't need it because it just snaps into some plastic up here. So this whole thing, it's two pieces of plastic, but they've been sort of pressed together and sort of riveted with little nodules, little nubbins, and then they've got a light pipe in order to go to the primary LED output, which I love me a good light pipe. I think it's a very clever way to do things. You kind of control the shape of your light with a piece of clear plastic. The circuit board is right here, and we've got it soldered in to the plug. So that's probably the unmovable part that needs to be desoldered in order to take a look at both sides of the circuit board. That is going to be a hot operation because, yeah, that's a lot of solder on this thing. So let me see here. I guess that's got to go. So let's get the plug out of here, and we'll take a look at what exactly is going on the circuit board. Is it actually grounded? I don't see anything around the ground pin, but we can't see the other side of the board right now. So I think it probably is. All right, so we'll get this. We'll get one of these. We'll get the big tip. We need the big iron tip so that we get that inertia, the mass inertia, the big tank of heat that we can draw upon, as well as the 300 watts of soldering iron power that I normally have. Got to turn it on. I haven't turned on my soldering iron in a little while, which always feels kind of weird. All right, so I'm going to put this thing in the vise, tighten it up on one of these caps. Who cares if it explodes? And then I need pliers, so I'm just going to get my wire cutters over here. And then I don't know if we really need to refresh the solder, but I will put new solder on it so that we can heat it up properly with a little bit of that rosin core. I could use Tachyflux instead, but oh yeah, that flows over nicely. Very quick. Technically, I could use hot air on something like this, but I think this will do just fine. And then I need to get at that pin. Oh, this will still stand up. Good. Good. Yeah, this is where the 300 watt soldering iron really comes into its own. All right, so that should refresh all the solder. This isn't a super old device, so this the solder is fairly malleable. Although is this Rojas? I don't think it's made in Maryland, and it should be fairly recently made. So I'm going to apply heat, and then I'm going to wait. I'm going to wait, and I'm going to wait. Forceps would probably be a better idea here, because then I could lock them in. Now, is this thing going to cooperate, or is it being held in by the plastic? It'll eventually melt the plastic, too. Looks like I'm going to have to use Chip Quick to lift the board out. No, I don't do the Rossmann flux flood. I don't believe in it. Too many chemicals. Now, instead, what we can do here is we can use something called Chip Quick. Chip Quick changes the alloy of the solder beneath it, or sorry, that you would introduce it to, and it creates a much lower temperature solder. I don't see any evidence of there being a plastic. Oh yeah, plastic press for the individual terminals. Yeah, you're right. You right. I was hoping that would melt away, and maybe it would after a little while. But if I hit this stuff with Chip Quick, it should give me time with the heat that I've provided in order to remove the circuit board by lifting it. Using a slightly excessive amount here. And then what I'll do is I'll just put the screwdriver under it. I'll put a little pressure on it. And I just apply an excess of heat to each of these so that they remain molten longer. Chip Click is like magic. It really is. It's like magic. Let that cool down a little bit. Yeah, that's Chip Quick. It keeps your solder molten longer, and that allows you to remove stuff. When you use it on surface mount devices, it's even crazier because you're like, all right, now I've applied all the Chip Quick, and then the chip falls off. You expect to have to come back around and heat it again, but that's not the case. It just falls apart. So this tube here was $30. Well spent, but a little expensive. So I try not to use it all the time. I try not to. All right, let's take a look at the circuit board. Let's see what we got. Got a nice empty desk. My God. I'm waiting on circuit boards. I've ordered a bunch of circuit boards, and I'm designing the module testing module circuit board. So we're just kind of in limbo until these parts come. I've also ordered a bunch of what do you call it? More of those Wentai boxes, more of my organization boxes, so that we can properly put away all of my parts, and we'll be ready. There's a lot of stuff on this board. There's actually a lot more than I had anticipated. Boy howdy, would it be nice to design a board like this where you've got all this room to spread out. This is a 4-layer board because we have these vias that are here. Let me get a pointer. I need something to point with. I need a pinter. Where's my pin tool? Oh, there it is. It never really goes far. I don't know why. So we know that this is a 4-layer board because if you look, there are these vias that are completely surrounded and are not connected to anything. You wouldn't see that in a 2-layer board. So we're 4 layers at the very least, which probably is why they're able to make this so goddamn dense. They've got a chip on this side and then a chip like right nearby, and then oh my God, it's a mess. I could probably design stuff like this at this point. I would like to, get into 4-layer boards. I need to actually email my AutoCAD person because my copy is saying, hey, renew your license in 30 days. And I'm like, wait a minute. I did my due diligence. I did my streams. Maybe I need to just, quietly poke him and be like, hey, what's going on with this? And he could be like, you're fired. And then I'll cry. No, I think it'll be fine. I think he'll just have to hit some buttons on his end. So we've got a couple big chips here. One of them clearly is an RF microcontroller, but let's see if we can find anything in the ISM 4343. ISM 4343. Let me get a window open here. ISM 4343. Inventec Systems. Embedded 2.4 gigahertz Wi-Fi and Bluetooth. Warning, count parameter must be an array or object that implements accountable in Atrens Bonds Web 9 Bosch Web C blah blah / IPG itinerary public. Okay. WN Bluetooth and etc. So yeah, this is a product that is just simply an embedded Wi-Fi Bluetooth module. Cortex M4. That's very, very, very powerful for what this thing is. What EDA do you prefer? I grew up with Eagle, right? I started with like PCB 123 and and those like MS Paint style PCB making softwares, the ones that were for hobbyists, and all the hobbyists then went over to Eagle. And in the time, in sort of the interim for when I got my degree in EE and did all that stuff, everybody switched over to like FreeCAD and whatever that free Linux PCB software is. Whereas I sort of remained with Eagle for a while until Eagle was bought by Autodesk, and now Fusion has Eagle as part of its functionality. So Fusion 360 does 3D design, and then it also does circuit boards. And it's sort of, that is my level. Yeah, KiCad is the one that I was looking for. I use that stuff because I used to use Eagle, and I have a lot of very old parts libraries. What's up, Proteus? Insert nice hello message. Hi. So yeah, anyway, that's what I use. I use Eagle, Fusion Eagle. And I've been getting back into it because of the advent of $5 PCBs, these batch process PCBs that you can get made. I can, for $20, I can get a 4-layer board made. So I could be this dense. I could do this density. There's the LED, by the way. It's something like a blue-green, simple little outfit here. So whatever RF software they've got on this thing, and then whatever analysis software I'm guessing they have over here, this thing has 2 lines coming out of it that go to the other microcontroller. So an I2C something or other. What is going on there? What the heck is that? They just decided to drill. Oh, what the? What in the hell? Wait, why are there so many holes around this thing? That's basically what I thought. It's more embedded ESP32. Yeah, they're not going to stoop to the lows of using an ESP32. They're going to use their ARM Cortex super duper one. Well, let's look up this one, but then we gotta look at the one with all the holes. I don't know what the hell's going on with that. That's so weird. How would you do that? MC126WZ. Okay, so AHC126. Look that up. 126 datasheet, PDF on all datasheet, and it's a little more confused than it probably should be. Quad buffer line driver, quad 3-state buffer. I don't think that's the right thing. HC126WZ. WZ05208. Oops, 108, 208. Nope, how about just WZ5208? 400 pieces, silk rose petals. Damn it, we're getting into kind of like an eclectic ASIC area. AHC126 datasheet. And then SNX4 AHC126. That doesn't have any evidence of SN, but that is a quadruple bus buffer. Why are we buffering our bus? What's so good about our bussy that we need to buff it? It does look like it might be the right thing. It was blessed. It's so holy. Why would we be buffing this thing? What would we even be buffing? Code Rush, raiding with a party of 8 individuals. How y'all doing today? We're taking a look at this thing. This thing that I was supposed to hook up to the power line so that the electrical people could determine whether or not we needed electrical stuff done. And I said, hell no, I'm not plugging that thing in. You don't get to look at my power. You want to look at my power, you get a multimeter. You look at it right now. I ain't plugging no shit in so that you can remotely monitor my power lines. So this is a bus buffer. Why are we bus buffing? What are we bus buffing? Are we coming out and around and back into ourself? What the heck? So bus buffer. Maybe we're buffing, but no, we're not buffing between these two because this thing has a direct line. Does it not? Whoa, a little diode cluster. That thing's cool. This thing was made in Maryland, apparently, so it's got some cool stuff in it. But I don't know what we're doing with the rest of this. This NXP one has me really curious because it's on a drilled out thing. Is it a temperature monitor? PCT 2075. PCT 2075 data sheet. Oh, you guys aren't looking at the right thing. PCC 2075 temperature to digital converter. There we go. Yeah. So that's why it's on a drilled out thing. It's supposed to be ascertaining the temperature inside of the case, I guess. Or, well, but it's got vents on the back of the actual enclosure where this thing is. So I guess this is supposed to get ambient temperature. PCT 2075 is a temperature to digital converter featuring plus minus 1 degree Celsius accuracy over negative 25 to 100 change. It uses an on-chip band gap temperature sensor. What the hell is that? That sounds kind of cool. Yeah, welcome in, Raiders. We're looking at stuff today. We're going to be taking a look at some old Tektronix equipment too. That's something on 30 years old from my old college. So are these the guys who do these guys suggest drilling a bunch of holes around this thing? Why would you not use like a normal I2C temperature sensor? It seems like an odd choice. Like you use a Dallas semiconductor temperature monitor and then you just have it hanging down off of the bottom of your board. This is a lot of space for a temperature sensor. And then on old laptops, what I've seen people use is just a diode. You just measure across a diode. I can say what it's supposed to do, but I'd let the speculation continue. I mean, okay, I'm wondering why this temperature sensor and not a Dallas semiconductor temperature sensor. Because this one, it's just sensing the ambient temperature around this thing, right? I mean, that should be clear enough. That'd be the inside of the enclosure, and the enclosure has vents in it so that there would be sort of a natural convection. All this stuff above it getting warm and doing its functions would encourage heat inside of the enclosure, and so what they have is vents at the top and vents at the bottom. So the vents at the top, all the hot air, because you're plugging this thing into a normal socket. I assume you're not plugging it upside down. Even if you are, I guess it would be measuring a slightly higher temperature because all of this heat would go up this way. But you plug it in like this, and so your temperature sensor's down here. All of this stuff is creating just a little bit of heat, and that just a little bit of heat will then go out these vents, and then fresh air is coming in these vents. So you get a slightly better idea of what ambient temperature is. Which is a clever way of doing it. I mean, it's at least thinking about it a little bit. What's this one? That's probably an EEPROM. Is that a logo or is that an M? MX something or other. MXSC? What the heck is that? Is that a pound symbol? MXI? It's like a cursive. Man, that's really, for some reason, it's really hard to make out. MXIC 25V80. MXIC 25V80. 8-bit memory. IC, oh, it's a flash. It's actually flash memory. 8-bit SPI. 104 megahertz. So, all right, so that's what that is. That's just, you know, because you'll find clusters of microcontrollers and nearby you'll have some kind of a memory saving element so that it's able to store settings and then power off and then power back on. All right, so aside from that, there's the button input from the side and a whole bunch of like vias and test points surrounding capacitors. Don't know what's going on there. D203. I'm guessing that this one right here, the one that's surrounded by coils and diodes and big resistors, is some kind of a power regulator. So LNK? That, man, that's really squished, isn't it? LNX or K 6223 from P. I don't know what that P logo is. It's like a Flyers logo. LN. Let me get a better view of that. LNX. LNX 6230G. Oops. LNX 6230G. This little device has a lot of cool stuff in it. Oh, it's a TV. Okay. L623. I don't think that's right. The most driver for 3-phase brushless DC. That's not it. That's not it. That does not look like a K. That looks like a very space constricted X. We could try LNK 6230. But it looks like it's like messed up. INK LNK 6230 from Mauser. Well, there's no dash in it though. Energy efficient offline switcher with accurate primary side constant voltage control. Yeah, I don't know about that. Although it does seem kind of... Oh, no, that's not it. Oh, yes, it is. Wait a minute. Yes, it is. It's got that... It's got the cut. It's got the weird cut. It's got that weird cut. It's got that weird cut in it. So what the hell is this thing? Dramatically simplifies constant voltage converters. Eliminates optocoupler and secondary control voltage secondary control voltage control circuitry. Eliminates bias winding supply. IC is self-biasing. Compensates for external component temperature variations. Very tight IC parameter tolerances using proprietary timing technology. Jesus Christ. Okay, it's some kind of a voltage thingy that does voltage thingies. I was correct. It is the power supply. That's our power supply, but then all the way over here, we've got some of the capacitors and resistors and stuff that are designed for the AC line. And it looks like we've got a bunch of coils as well. There's our fuse. F102 is a nice little surface mount fuse. I've used these before in a design. Ting, Rev 17, 2021, 1015 from Whisker Labs. Whisker Labs. Uh oh, that was a pane of glass falling over. I guess it's okay. These get coils to ground, but then what is... there's a coil there. Are we monitoring across that? Maybe we're just stabilizing power, just in case it comes in all dirty. And then we've got R308 over there that's standing over on a bunch of big old thick resistors. They're very accurate 1 mega ohm resistor. Huh. Oh boy, hard to tell where it's going from there. Oh, there's the full bridge rectifier. So, oh, optocoupler. Okay. So are we triggering the optocoupler? Oh, looks like there's other stuff in there too. This is complicated. There's some weird stuff. I really don't want to look up U306, but I probably have to. Probably have to. I don't see any markings on it. Well, it's just because of my light situation. I've seen these setups for automatically getting the markings on chips, and they've got like a ring of LEDs that they can light up like individual LEDs on. It's pretty cool. I should look into something like that. That's our ground pin, and it doesn't look like we're using the ground pin. The ground pin appears, let's wait, shine some light under the board. I've got my pen light here. Okay, we are using it. I can see the inside. Wait, is that? No, we're not using it. There's nothing connected to the ground. Wait, but I thought this device was entirely for detecting stuff going on in your electrical system. For what reason would you ignore ground completely? That's very strange. I guess they're just looking at the input AC. Why would you ignore a ground fault though? I guess you have the other ground of the system coming in. This would be the earth ground that uses like the pipes and stuff like that. But you would still, I would think you would still want a reference to that for something. But I don't see no traces coming out of it unless there is like a micro trace like this one. The fact that I can see lighted all through the circuit board in that area is telling, but it also has a test point. So, and they also bothered to even have it on the thing and solder to it. There's got to be like a micro trace coming out of that I just didn't see. Excuse me, sorry about the hiccup. I need to go get my liquid so that I can drink. Now, what are these? These could be diodes, but they could also be op amps of a kind. 0AA1. Let's see if we can find this. So these are SOT, but not 223. They're 23-5, and it's 0AA1. LDO regulator with V out on pin 1. Now, I think I have some of these, but I don't know if this would be a regulator or if it would be... Why would they have a regulator like that? I guess maybe the power coming in isn't suitable for the micro. Sim pin D23, blah, 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 blah. I don't know. I don't think I buy that that's a voltage regulator because there's 3 of them sitting right here. Over here we have some different part numbers on it. LTFRW. The tough part is with SOT23s, they don't have a lot of room for markings. And so it's been kind of like the Wild West with these parts. They do whatever they want for markings. And so some of them share it, some of them don't. You can get a PDF that's a big Bible of markings for these parts. That's got to be a really confusing one because it's like a miniature SOT23.5. How would you even, like, why would you make that in ostensibly the same case layout? You could change just something slightly so that it's not like a don't talk to me or my son ever again scenario. It just looks like imagine designing a whole circuit board with these and you think you're building this giant circuit board and it turns out everything is like just like a 50% photocopy, a 75% photocopy. Very strange, very strange. All right, so I got big power lines running around here. They decided to do some big traces for different things. Big cap. Apparently the 0.1 off decoupling cap is a thing of the past. You don't need a 0.1. And I haven't finished reading that article yet that was posted in the Discord. But apparently 0.1 off is not, it's something that was set off in like the many years ago. I'll just say like the 80s and before, 70s and 80s, and they said 0.1 off is great, and then now it's totally irrelevant. I barely use decoupling caps, but I guess I got to put them on some of the designs, so I'll have to figure out what the new vogue value is. Hard to believe that those are regulators, but it's possible that they are, and they're set to different voltages, like 2 point whatever, or whatever reference voltages would be needed for these big deal microcontrollers. As far as sensing goes, it's very hard to determine what's going on. There are some small wires that go to the various phases, and I have a feeling what's going on is that this is getting, basically your electrical power is flashing in an LED, which is then going through probably an op amp, I'm going to guess. I don't really know for sure. We could look up. And they love their SOT23.5s on this board. K127. SOT package uses both bonding wire. Wait, what? Huh? That's not. What? AI. Oh, you fucking. You AI. K127 original, genuine goods in stock. That's always a little dubious. Well, it's K127. Double check. Light situation is abysmal. K127. Usually they'll tell you what it is, but it doesn't look like. I love it when nobody knows what the thing is and they don't tell you what it is. They just have a picture of it. Logic IC. Model number. See if that does it. Model number might just be their stocking number. Oh no, hold on. Okay, we're still doing okay. Operational amplifier. Okay, so why I went with short hair breed. Oh boy, what is this? What is this, Celia? Click on the thing, opens it in a window. Oh my god, is that the girl with the dogs? No, that's somebody else. Oh my god, that is a lot of hair. That I could do that with Willow. Just maybe on a slightly lesser extent. So this is an op amp of some type, that's fine. Anything special about it? Rail to rail. 2.5 to 5.5 volts op amp. It's like 4 other dogs floating around in there. Yeah, that's a little. I mean, if you really look at the seams of the shop, like you go to the corners, like over there particularly, you will find about that much hair in Willow hair. She was in here yesterday. She was hanging out, sleeping in her little spot. She kind of spills over. I took a picture of it. Hold on, let me use a picture of Willow. Picture of the puppy dog. Although I think everybody in Discord is sick of pictures of Willow. I am going to continue to post them. You will not be able to stop me from posting pictures of Willow. That's just what I do. But they don't get as much fanfare. Anyway, this was her under the desk, completely dead. That is a dead dog. I took her on a mile walk, so she just did not want to participate anymore after that. So she kind of buries her face. Like, she'll either curl up in this bed and it's like a perfect fit, or she'll splay herself out on top of it, and I feel like I need to buy a larger bed for her. Or she'll curl up in the bed and put her face on like the on the rails or whatever, the board, the thing that holds my desk together. But then there's this scenario where she kind of spills out onto the blanket. We'll never get tired of pictures of fur babies. Real babies, on the other hand, yeah, the real babies are little freaks. One image is enough, the rest, yeah. Don't need to share 1 million pictures of your kids. That's all right. Everyone has a different perspective on that one. Whether or not you should share 5,000 pictures of your children. As a now adult dog owner of both an adult dog and me being at least passable as an adult, I guess I understand the need to post 1 billion pictures. So we have a cluster of voltage regulators. We have some op amps. We have an isolator. I'm assuming that this is an opto isolator. I mean, you have an insert of power. You have these huge resistors here. You have sort of this network of enormous resistors that are probably taking your load, because I think this one is probably neutral. Wait, why would neutral go through a fuse though? Which one is which? Let's look up the NEMA power socket. North. Actually, I can actually just look at a plug that'll tell me. I don't have any with me. I don't have any around. North America power socket. North America power socket. This is not the right one. It's fucking hate. I hate what has happened to Google and AI and just all the. Can't. Where do we let this go? Why did we let this go? Fiduciary responsibility killed everything in the modern world. All right, so we have our power plugs, test button, blah, 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 blah. Which one's load and which one is neutral? We know, like, this stuff should be easily Googleable. And it used to be. This is next to useless. Although we are technically a type B socket because we invented electricity. This is why I use DuckDuckGo. DuckDuckGo is headquartered at my Wawa. They're basically right near the Wawa Foods Market that I go to. Pin out. That's what I'm looking for. So neutral is indeed on the left. So the one that we were looking at that seems to be hooked up to stuff is neutral, which I guess is a good indicator if stuff is really wrong, if you got some weird stuff going on neutral. And then this one is load, and of course that gets the fuse. But load, on the left, this one is load. I don't really know where that's hooking up. Huh. I do not know how this thing is doing its monitoring. I mean, it's obviously got a bunch of op amps on it, and anything you monitor, you'd probably be putting through that opto isolator. But the opto isolator makes it so that, do you have nuance with an optical isolator? It's no longer an analog signal, even though they are putting what comes out of the opto isolator into an op amp almost immediately. And I would assume that that op amp has some kind of role in speaking with the microcontrollers. There's a lot more going on with this device than I thought. And it's not as shady as I thought it was. Although, who knows what the hell they're doing with the data at that company. I just don't want to give them that data. But it seems like their power supply monitor is an actual fairly capable device. Maybe it's going to look up your network traffic and give them an insider tip. It's got a pretty decent design, though. I mean, they've got a temperature sensor out here that's isolated from the rest of the board, in spite of there being 4 layers here to work with. They've stripped them all away and drilled a bunch of holes in their PCB in order to temperature isolate this temperature sensor. And so what'll happen is all the other electronics on this thing will create an ambient sort of heat that'll cause there to be a convection flow of wafting air through the device, so that this thing actually gets air from the outside. Enginuber! Oh, Cilia, that was a Cilia Russell. Cilia Russell is gifting a tier 1 sub to Enginuber. Cilia, thank you so much. It doesn't do anything unless you pair it with the app. Well, you pair it with the app in order to get it onto your Wi-Fi, and then it does stuff. But, you know, it's obviously sending data, usage data back home. I don't know what other data it would possibly use, but I'm not going to power this thing up. I mean, it is a nice design. It does look like there's a lot of very interesting stuff going on here, but I don't have any use for it, and I don't think we can do like a takeover of the microcontroller. I was hoping we'd find like an ESP32 and we could just throw Tasmota on it and be like, yeah, I've got a power line monitor. Nope, doesn't look like it. I mean, that's a shot in the dark too. I mean, you never know. You can look up the Tasmota devices online though. But yeah, so as far as it goes, 2 giant microcontrollers. One is doing probably all the different monitoring, and then the other one is doing the Wi-Fi. And unfortunately, we can't do a takeover of the Wi-Fi. Same what? You wanted to take it over as well? It would have been nice. I guess you could look up the Tasmota device list and see if there's something that monitors your electricity. Because yeah, this would be the main current control power supply, and then these are like the digital and analog voltages over here. These 3 guys right here, 3 amigos over here, are then providing power into here. Man, designing this thing must have been a beast, because there's a lot of stuff at a pretty dense board. We're using more than 4 layers though, which is cheating in my mind. Let's check to see that that's actually an opto isolator. It might be something else. A814 datasheet. That's going to come up with a lot of stuff. Those 2 MCUs are probably bored with the work they're tasked to. Yeah, getting on Wi-Fi for like a Cortex M4 or whatever. And then this thing is what? LPC 4370. I don't know what generation that NXP is, but this thing is a very powerful transmitter. People seem to think that because you're doing stuff with like Bluetooth and Wi-Fi, you need to have one of these like blisteringly fast multi-core super duper chips, and it's just not really true. You know, we have like ESPs that do the jobs of these things. But if you're selling your device for a certain amount of money and your engineers are not great at scaling things down, and maybe it actually is just a system that they pulled over from another product. Ooh, a little bit of acid reflux. That's always fun. That's a result of having a hoagie from a supermarket. They do not make them very well there. Sometimes they do. Sometimes the hoagies are pretty good from supermarkets, but these were the non-good ones. This is just a grab-and-go kind of lunch, and it's way too much oil, way too much oregano, and blah. A814. Silicon PNP epitopalaxical base MESA type. Did Jar Jar Binks write this? What is this? That ain't what we're looking for. That's something old transistor. There isn't even a picture of it. How hateful. Oh no, there it is. Yeah, this is a TO220. We're not looking for a TO220. Power transistor, 4-pin phototransistor optocoupler. That looks a little closer. Although through hole. But I'm guessing that it's just an optocoupler. ESP now comes with support for 5 gigahertz networks. Wow. Why spend $15 on a chip that can just do Wi-Fi when you can spend $5 on that and do both Wi-Fi, Bluetooth, Zigbee, and GPIO? Yeah. And it's powerful enough that if you need more I/O, you can just put a port expander on it. All right, let me get my seltzer so I don't digest my own organs live on stream. I'm back. Did you guys keep it together while I was gone? All right, so yeah, this is a pretty interesting little device. I mean, there's a lot of stuff going into it. It seems like they threw way too much computational technology at it. You know, there's not really that much justification for having 2 giant processors on this. I'm sure this thing has the amount of GPIO that you would need in order to monitor power lines. There's just a lot of stuff. There's a lot of stuff here. Probably a lot of op amps in these chips. And then analog inputs into which one? But then you have your for some reason you have a buffer, a buff thing in here too. It seems like maybe they wanted to have something do things the way they normally do stuff, and they sort of catered it to the job by having buffers and stuff. Seems a little weird to me. Maybe they did it so that the Wi-Fi element, like if it got such a spurious signal that it blew up the microcontroller, this one could go, it blew up, boss. Maybe that's why that's there. So there's not one singular point of failure if you're plugging this thing into like the worst power you can. This seems to be the primary leg of monitoring. I don't know exactly what it's doing here. A lot of coils on these things. A lot of coils on the power input. And here's where they're rectifying it. Here's where they turn it into the DC wave. The DC sawtooth that then gets filtered with the caps to become DC power, and from there they're using these low-level voltage regulators. Attempted to desolder the ESP8266 that's on the P1S printer and put on an ESP32C6, as I only need power and ground, TX and RX. That way I can shut down the 2.4 gigahertz Wi-Fi there. Yeah, I enjoy tasmotizing things like those lights. I still have to get the rest of them. All those lights over there, I need to physically get into the device in order to tasmotize them. But what I can have is a second one of these status lights, and the second status light will use whatever that API is on TrueNAS, so that I can have a server drive status. So if the light turns on and it's red, we're in trouble. I need that because I don't have any other kind of a monitor for that server. It doesn't, like, for some reason TrueNAS never thought like, hey, maybe people want like an LED output on this thing so that they could see the status of their drives. No, you have to buy the professional expensive servers that are sort of bespoke hardware in order to get that functionality. And like, I sit here in this room, so I am right near the server. I can look at it. I understand that a lot of server stuff is super remote. Like, you don't need to get anywhere near your server usually. But in my case, the server's right here, so it wouldn't be any skin off of my back if it also included some kind of a drive status LED. But I can add that with Node-RED and the REST API for the server. I can set that up, hopefully. That'll be pretty cool. In the meantime, I got a bunch of test equipment from Drexel, and it is probably 40 years old. Let's go with 30 years old. Let's go with 30 years old and assume that all this stuff is from the late 90s so that we don't feel older. I'm in the process to make all of my homemade devices into Zigbee just to free up some Wi-Fi clients. I'm doing the opposite. I'm actually putting everything over to Node-RED and using Wi-Fi for all of this functionality. I think Gonad is going in a similar direction, but without the Node-RED part. He's moving a lot of his stuff over to Wi-Fi. Now, for certain devices, of course, I don't trust Wi-Fi, but for little interactivity things like the light switches and stuff that I have around here, it really helps me to not have a lot of wires floating around, and I have them on their own little intranet. Well, it's not really their own little intranet. They're on the intranet with everybody else. They've got their own IP addresses for everything. They've got a little cluster. So I guess if my router goes down, I am going to be in trouble because I'll need to reassign everybody to their specific IP addresses. And whenever there's a power outage, things get kind of out of sequenced. I have some sequencing issues with power outages. What is this? This is TNC4? This is a TNC 4.0. Paul Stoffrigan did us a solid and wrote on the back what device these things are. That has to go back in here. Okay, clear the desk, because I've got this huge rack. Not what you guys expect. It's actually just this stuff right here. These things are rack devices. So I want to take a look at this arbitrary waveform generator. Which one is that? Programmable digital multimeter. Programmable power supply. Stream status. We need to print like an on-air flag for the top of this thing. Programmable arbitrary function generator. Universal counter timer. That's pretty nice. Programmable multifunction interface. What the hell? That's a weird one. I'm doing the same with Matter to use the Wi-Fi. With Matter to use the Wi-Fi. Oh, wait, huh? Those are what, 3-4 units? This is 1U. So yeah, these would be, what is it, 1, 2, 4U. I'm going with 4U on that. Node-RED for Zigbee to my home automation server and have Zigbee gateway and it reaches all corners of the house. That's crazy. On the far side of the barn. What word did you not like here is you didn't want to send it the first time. Zigbee, automation, Zigbee gateway, corners of the house, fair side of the barn. None of that is offensive. There's nothing in there. Unless I thought Zigbee was some new amazing curse word that we all suddenly made up. Hey, my prescription's good. That's nice. Nice to know. All right, so these things. This is a Tektronix TM5006. 6 being the number of test equipment slots that it has in it. I guess this thing is just designed to take in test equipment and hold it together. At Drexel University, we had these lab benches that have these huge racks. I mean, these kinds, like the rack stuff as part of the desk. It was built into the desk. Man, I would have loved to get some of those desks, but I think they probably still use them. They were like fire retardant desks that had these wonderful, like giant rack pieces to it. Kind of amazing. How dare you call me a Zigbee? But apparently these things are old, and so newer equipment, newer test equipment is quite a bit smaller than these things. These have a lot of very interesting electronics on it. Check out Bother's huge rack. I know. I got 2 of them, and they're bouncing all over the place. All right, let's get this thing out of here. And I think we only need to get, oh God, it's a Torx bit. It's a Torx bit. Let's get a Torx bit screwdriver. And this thing is older than I am, so it probably needs a bit of torque to get it open. This Torx bit was sticking out, so maybe. The best part, everything inside of those is through hole. Oh, that's pretty cool. You could really crush somebody with those. Yeah, I could win a boxing match with these things. These devices make me feel so old. Look. Ow. Okay, that was in there. Is that a triangle bit? No, they're just Torx. So these are just like extra little locks to make sure that they don't fall on the students and cause a huge lawsuit. Because I mean, man, we poked the shit out of these things when we used them in college. We didn't really use the arbitrary waveform generator that much, though. We had our own, you could get an oscilloscope from the back room. You had to get it through like a little booth. But, all right, so then I should just be able to pull this. Okay. Oh, pull these and get it out of here. It should just come out with those two little pull handles. I miss test equipment that looked like that. I didn't know this shit would be so nostalgic for all of you. Well, I was saying that they're 20 years old. You're the one that said 30. All right, that worked. Oh my God, and it caused motion to be at the front door. Ah, son of a bitch. So this thing has to be used. I thought that this would be a little bit more universal. That I would be able to get it away from the TD whatever 5006. Maybe there is a base that I could put it in, but it looks like it's pretty bespoke to this card rack. Damn it. Well, it's what it's. We're still going to take a look inside of this thing. Proper test equipment. Well, let's see what we got here. So, all aluminum, all perforated. AFG 5101 programmable arbitrary function generator, huh? This could be quite useful, but implementing this stuff requires me to get a new lab because I would need to have a rack sitting above everything. There are probably things you can plug into here that would be like, you know, your AC input. The sniff test. These things smelled like a shed because they were left in a shed. For continued fire hazard protection, replace with the same type of rating of fuse. Oh my God! That hiccup was very damaging to my esophagus. Hold on. Jeez, in the middle of a sentence. Oh my God, there's a Drexel University number on it. Don't report me to the cops. All right, so we got to get inside of this thing, and there's 250,000 screws. I guess I'm going to start by wiping off the front panel. I'll just be at least nice to this thing. Reverse engineer the interface. I can probably just look up the pinout. There's probably just like, oh, you know, put a bunch of power into these two. And it looks like our PCB is shredding. Uh-oh. We got a case of the old PCB on this one. Oh yeah, getting stuff like that from people who smoke is not good. Regardless of what they smoke, it shouldn't be around electronics. It really does have there's bad stuff to it. That is wrinkly. These are old PCBs. That may not be. Did I permanently borrow it from the university? No, it was during the big lab clean out. That was many, many years ago. And a friend of mine was the one who procured these, and then he gave them to me because he had no use for them. So these have been sitting in a shed for a little less than 20 years. Well, I'm going to need a much larger screwdriver than this. And since this kit doesn't have that, I need to get the big kit. It's the first time I've had to get the big kit of screwdrivers in a long time. No, no, no. They're not stolen. My friend got stuff from the Drexel Optical Lab, too. And he found this one, like, kind of prism thing that looked like somebody had built it. It looked like somebody made it themselves. And he put it up on eBay, and it sold for, like, $600. Because apparently it was a fairly sought-after thing in the end. I don't know the details. This is too big. This is too big of a screwdriver. Slightly smaller than that. But again, that's not me. I wasn't doing that. But this was just recently given to me because it's been sitting in my friend's shed and he's trying to kind of clean stuff out a little bit. And since I'm the electrical guy, I, of course, for some reason, always get this stuff from people. This and dead computer power supplies that I don't want. Hey, I got a computer power supply. Do you want it? No. No, you keep that to yourself. You never tell me about that again. Because while, yes, maybe there's some case where I would need an old computer power supply to get some giant capacitors or a whole bunch of wire from, you really only need 2 of those, and then you've got a storage issue. But an arbitrary waveform generator is not something, it's not a gift horse that I'm going to look in the mouth. That seems to be something that might actually be pretty useful, depending on what shape it's in. The front panel is, of course, in pretty abysmal shape. It was not covered in the shed, and it's got shed on it. But this stuff might actually be pretty good. I think that frees up the side panels, but I don't know what screws free up the side panels. Yeah, because that's not budging. And I got all these screws here, but then I've got these interstitial screws. I'm never going to remember where all of these go. Oh, and there's evidence of tampering. So this screw's a little chewed up. Need to throw out my collection of PC power supplies. See what I mean? They just multiply if you let them. Ah, shit! This is too small of a bit. It's hurting the screw. We have something that'll work. Those are for the weird ones. This one down here. You want the largest screwdriver that'll fit, the largest bit that'll fit. But these are fairly seized up. Just try to use the electric on it. Oh, that actually worked really well. That worked really well because I was able to put pressure down on it. Woof. I don't know how many of these I need to remove to get this thing off. There's like plastic stuff on it too. There's always a little bit of madness in the construction of test equipment like this. Okay, so it's 3 discrete pieces? Or wait, this pops off. Or does it? Or am I? Let's see. This looks like it pops up, so I'm going to test that theory by popping it up. Oh, it pops up. No, it shouldn't pop up with this. Yeah, there we go. Okay. All right. So, Jesus, look at this stuff. This stuff is 40 years old. Oh, no. Look at these things. Oh, my goodness. I feel like we're in Star Wars. I have some rack equipment that uses these sockets. Huh. I guess this is like a telecom thing, isn't it? Jeez. They had plenty of room when they designed these things. I don't even need the microscope for this. It's too restrictive. 7400 series. Oh my god. So we have 7400 series chips in this thing. A little bit of TTL logic going on. Neat. Here's a little release leg. Things look to be in pretty good shape in here, though. The solder looks okay. It's just the external interface down here where we've got some troubles with the solder looking a little funky. But I would like to get a little further deeper than this. Question is, what side stuff needs to go? Well, it looks like we got to release these. Then I think these probably are next. Look how densely this thing is designed. Can I like mix and match the different cards? The auto screwdriver is allowing me, the thing Mahala sent in, I'm able to actually like push down on them. So that helps me remove the crusty screws. Otherwise, with like a hand screwdriver, I might not be pressing down as much and it'll chew up the sides of it. Oh, so that doesn't want to move because it's got the big anchors in it. Although these look like they unscrew. Oh. What are they? They've got like a... Yeah, they have like a hex thing on the base, these pins. So I need to get my deep sockets. They're probably English sized, but the metric seems to be somewhat gripping them. And I don't think I have that deep of an English socket in this size. I actually might. Do you think they were using metric exclusively on this thing? I'm gonna have to watch this in reverse in order to put this thing back together. This thing is built like in just this weird way. Luckily, these things go pretty easily. I'm going to take all these screws out, and then everything's just going to fall apart. It's just going to fall into a million pieces. What I really should be doing is cleaning them off, just wiping the fronts, and then powering up the whole thing, but I wanted to get into it. Said I was going to make a benchtop power supply out of one, but then never did. Yeah, that's tough. A lot of people do that, and you can just buy adapters to make benchtop power supplies out of computer power supplies. But what I ended up doing, for my own purposes, because the Agilent power supply, again, liberated from Drexel University, the Agilent power supply, that one is super accurate, but it doesn't have a lot of current. There we go. That's what I was hoping to have happen. Oh, so there is a lot of empty space. Look at all that empty space. I wonder what other accessories I could be adding to this thing. Man, everything on this is built like kind of universally. Man, look at all that empty space. Jeez. Jeez Louise. So theoretically, I guess I undo... Okay, those side screws are just bracing it against the front panel. And then these just pluck out. Yeah, there it goes. I scratched my microscope. What the heck? Card plane connectors, huh? Someone has gotten to it before you? How do you know that? But yeah, what I did is I ended up buying like a 52-volt power supply board, and then one of these little adapters, and these are from Easy Hook, which is an American company, and they make really nice test, hookup things. And I was able to buy the enclosure for it as an audiophile enclosure. Apparently the audiophile people who do DIY stuff love to buy these enclosures and make their own stereo equipment out of it. So I did that, and then all the aluminum panels, the thick aluminum panels, are all able to be removed, and I could put them on the milling machine. So I was able to mill out all the different holes and stuff for it. I probably could do a better job of it today, but back then I did okay. Okay, what's holding you in? It appears as though there are two SMA connectors on this one. Are they permanently holding it in, or can I get it out still just by unplugging? I should just be able to unplug it. Oh, and it looks like I found a spider egg sac, or that's hot glue. That might be hot glue. Theoretically, this should just unplug, shouldn't it? I shouldn't have to release these. These should be just press fit. Unless they're like... Nah, see, that wouldn't make sense. This thing should just come out. There's nothing else holding it in. So, we apply just a little bit of force. Scratch up my hands on them. There we go. I got a couple of these connectors. These are nice, though. This thing cannot be cheap. This thing has to be really expensive. Another little functionality piece of this whole equation here. One potentiometer on the whole thing. And the rest of this NES 529. Yikes. 74HC409. 70HC409. Some Motorola parts. MCN 616. 74HCT 374. I used to know what all these were. I had some 7400 series memorized. Yeah, it's a. Wait a minute, that's the Nintendo processor. Hold on a second. I have no idea. But these are looking pristine. I expected more dust. Yeah, a spider did make residence up here. That is definitely a spider web, but an old spider web. Hopefully not recently, because that would mean we have more spiders down here. Yeah, that's definitely a spider's house at one point. There's no dead spider around it. Love the audio cases, but I never found somewhere to buy the internals. Huh. I assume you have to acquire them yourself. You think there would be available listings. I'm wondering about all of these PCBs. Look at those traces. And there probably was never any water contact. This is just age. Age does that to some of these circuit boards. And if I took like a pin tool to that, it would scrape off. Spider realized nothing else could make it its way inside of the cage. Spiders are like that, man. Their existences are very strange. They spend just a ton of time with absolutely nothing going on at all, and then all of a sudden it's eldritch horror, and they die in some horrific fashion. A life of just sitting. I don't have to eat this year or next year, but then I'll suddenly get eaten by a thing with 1,000 legs. Damn, this is some old school stuff here, but I have my concerns regarding these traces that are all but obliterated for the passage of time. These are particularly concerning to me. My Google Foos failed me in the department. Sort of them drive from China. I don't know. Yeah, I don't know about that whole scene because I found the enclosures and bought them, and then we had the 3D printer project and the power supply project used those. These aren't done like that just to give it more copper. They're actually wearing away. Like moisture has gotten in and behind the traces and warped them. They may still work, but they could also crack at any point in time, which is a little bit worrying to me in terms of operating these things. And do a little capacitor check. Do we have any? We don't have any notable capacitors on this. We have our decouplers and those big guys right there. That's tantalums over there and over there. A lot of 1% resistors in here too. Those are nice connectors. Those are very nice connectors. Would conformal coating help the PCB? Well, it did. I mean, the solder mask can be considered a conformal coating in this case. The solder mask, being a conformal coating of sorts, has failed. So I don't think a conformal coating on top of that would. It's possible, but I'm not too certain about that. I mean, if the moisture got in to the solder mask, then it's probably going to get into conformal as well. These are decoupling capacitors. Over 7400 series. I do not know what this precisely is doing, this board, but it is cool. It's just nice to be able to inspect things. What's that in the middle? Oh, it's a variable capacitor, C100. Guess they built the whole thing about it. C100, right in the middle of the board. That's neat. All right, put that aside with its buddy. Hey, what is this one? It has a little daughter board on it. What? What the? Wait. Oh, this is that. We've seen this before on test equipment. These are extremely precise resistors. Like extremely precise resistors. Yeah, we've seen this before. We looked it up, and it's an old thing that they used to do where they had this daughter board that had these very, very precise sort of PCB level resistors. It's a really strange setup, but apparently that's part of test equipment. Let's keep digging. Let's get this other board out. Etched ceramic resistors. Yeah, I didn't know that they were a thing. So this one has a brace on one side. That may be able to come with us. This one should come out. I don't know if it'll hit up against this. Let's see, does this one have a connector on the end? It does. Okay, so I can wiggle this one out maybe. Oh, that's screwed on, I see. It's just... Ah, there we go. All right, this one, clearly the power supply. Got a lot of interesting stuff in it. Woo! Big capacitors. Now, are these still good? These might be pre-capacitor plague. This is definitely looking like a device from the 80s, though. I'm a device from the 80s. Do you have a date anywhere on these? They weren't too into giving you too much information. Tech out version 1.1. Everything is through hole, except for this stuff right here, surface mount. Early surface mount. This is an arbitrary waveform generator. Damn, 1A. That's a PNP. Is that NPN? I think it's a PNP transistor. 1A is one of the oldest markings on surface mount transistors, apparently. It's funny they would decide to do one little board in surface mount and conformal coating. Or the tunable capacitor, what's the crystal frequency that's right next to it? Why are you asking me such specific questions? Everything's so big, it's hard for me to navigate. 6.144 megahertz. A lot of stuff in here. We got our old school cans with old school heat sinks around them. We have, I think these are, what do you call it? You don't call them relays. There's something similar to a relay that's, what is that called? I forget what those are called. Damn, I used to know that. No, not delay lines. No. It's like a relay. It's basically you have magnet terminals and then you have your contact terminals, but it's like the same thing as these. They're little glass cylinders that have like a little flapping thing in them that are activated by a magnet. Reed switch. There we go. Reed switches. These are basically reeds inside of. I worked with these before for that brain monitoring thing. Those might be coils. No, I think they're resistors. What else do we have on this board? I mean, big capacitors. We got all kinds of regulating things. Transistors. That's a 3906. Hey, that's a common one that we use. Oh. These are made in West Germany. Whoa. West Germany. Oh. This is an old device. This is a fairly old device. Just got awkward. Hey, maybe they'll split up America too. All right, anyway. Oh, full bridge rectifier. Bunch of fuses. So yeah, this thing is providing power to the rest of the test equipment, probably not the rack stuff. The rack stuff will be making its own power and distributing it. But oh god, yeah, this is where things get a little hinky. Like that right there could be severed. It's probably okay, but things are not looking. This is looking a little grim over here. So this is like, don't leave it plugged in because it could start a fire. That doesn't even look soldered. I think those are vias anyway. Those may be okay. They might be worth looking at them. Oh yeah, it might be worth testing them before actually trying to see. I don't know. Maybe I just power this thing on and see if it bursts into flames. My daughter started school. They still had unupdated maps there that had USSR and West and East Germany. Jeez. Yeah. So the hourglass turns. What am I trying to say? I don't know. Whatever. Time goes on. We deal with a lot of old stuff here. At least we're out of the age where most of this stuff was like asbestos and and horrible chemicals, right? And the solder's got lead in it, but otherwise it's probably pretty benign. As far as the caps go, I don't really see any damage. I don't see any leakage. I don't see any bulging. So I think we're probably okay. Whoa! Look at that! And a piece of test equipment? No way! A piece of test equipment. And we've got a 7805. 7805 is a 5-volt regulator that was very popular in the days when, before they invented fire, back in the old times. I have entire bins filled with 7805s because they are just that popular of a regulator. They're extremely popular for old school stuff back in the era of TTL. Because you get you get about an amp out of it, and an amp is about as much current as any sort of a device really ever needs. Yeah, they're still used and made and everything too. This was introduced in 1981, made in the early 90s. God damn it. 30, 40-year-old test equipment. All right, try to pull this, but not pull out any of the stuff. Really should just use this one via in the back. They were quick, easy, and stable. Yeah, but they also made a lot of waste heat. You could really heat something up. I had a blue LED. I had one that was running a blue LED, and it would heat up the entire device. Okay, so this is probably most of the actual test and analysis stuff because we actually have quite a few of these little precision boards on here and a lot of support equipment. This one was towards the center of the device. I don't see too much, or if any, I don't see any wrinkling on the thing. My finger knows that well. Yeah, these things will chew you up. Whoa, here she comes. Watch out, boy. She'll chew you up. As I asked about the crystal before, I'm half expecting an X86 or something under the hood. I don't know. I don't know the brains. I'm guessing that the other boards are the ones that have more brains than this one. All the Intel chips? Yeah. That's actually probably where the... Hold on, let's take a look real quick. This would be the topmost board right here. And this one also has a card edge connector, so this one's probably dealing with some of the connections with external devices. Like those, yeah, this one's dealing with digital interface. Intel 1980 L8S211, so P82-291. These are probably EPROMs. Mocell. Elm 393. 3-volt power module. Oh my God. Wait, lithium. This is like a battery? That thing's probably gone real bad by now. GPIB. Yeah, GPIB. Good old GPIB is how we would hook up LabVIEW to our equipment and have it run automated tests. 8085, what's that, this one? 8279? Is that 79 for 1979? I think it is. Yes, it's the year 1979, and we've invented digital brains. Intel 80. Oh, 8279 is a display controller. How do you guys know this stuff? Are you just searching it real quick? Oh, 8085. There we go. The good old 8085. Intel, 1976 and 1980. The 8085. Ah. Well, this would be the brain, and it's in a socket. Boy, that's not a lot of brain for a lot of frequency counter. So yeah, this is probably where we're making all of the frequencies, huh? Got a lot of adjustments going on in here. A lot of adjustments, a lot of surface mount stuff, a lot of density, a lot of transistors, probably a lot of op amps too. And then the 70HC 4094. I've seen a lot of these. What's the 4094? 74HC 4094. All these were like similar devices from companies, from different companies that were making it. There were little variations in the power in the actual what do you call it? In the functionality of the devices, very little variance, and you had very little variance of the part numbers. It'd be 74 something something number. 8-stage serial shift register. So I guess that's part of the frequency counting or the frequency generation. ALU, maybe. I don't know where it would be. The front panel is an interface to all that stuff, and then all the controls. So all of my button inputs over here. There's actually a lot of stuff going on in this thing for what it is. Very clean on the inside, very dirty on the outside. Let's try to clean off this front panel just a little bit. And then we'll knock it all back together. Because I don't know if I don't want to go too much further taking this thing apart. As fun as that would be. Let me just do, I guess, Windex. Nice gentle Windex. Reformulated Windex. We're not using Windex from the 80s. So it should be pretty easy on this stuff. Man, to think, all that this thing does, we could do with an Arduino nowadays, without all this I/O, and all these chips. That cleans up pretty nice. I'm not exactly going to take what do you call it? Whatever that stuff is, the peroxide solution. I'm not gonna brighten that up in that way, but just getting the dirt off is nice. Let's get all that dirt off of this thing. Make it shine. All the dirt and the spiders. Get all that out. Yeah, I'm not gonna retro bright. I know this is a lot of buttons for an 8086 to be managing. I've used these before with weird timings for trigger signals, where you'd send an external trigger in that would then trigger another one, and it would make like a weird waveform. If you've seen Intel 8231 or an AMD 9511, they seem to be in the Intel camp on this one. So I don't think they're going to be putting AMD parts in. You find AMD in some shocking places on old equipment. And then you get shocked. Ah, it's AMD! Alright, looking pretty good. Next time you're wearing a bib. Autoline filtered data program, arbitrary, different waveforms over here, triggers over here, got our modes, and then we can enter numbers over on this one. Probably does just about the same as my as the little one that I have. A trigger input, sync output. What is this one? Marker output. This is so you can get your scope to see the waveform properly. You can move your marker around on it. And then you've got to hold in here, sweeps, VCO, FM in, so voltage controlled oscillator input, AM input, and then one singular output all the way over here. I smell onions. I wonder if somebody's cooking something today. Onions smell good. Although I don't know why somebody would be cooking onions, because I thought we were doing fish today. Oh well. There's a lot of opinions on how retrobrighting affects the structural integrity of plastics. Oh, is it messing with the mer chains? You don't mess with the mer chains. I don't remember which one of these went where. Uh-oh. We know the one with one singular output goes over here. And I know where the two ones with the output cards go. So this one is all the way over here. This is the big power input board. I'm gonna get them on their little racks, and that plugs in back there. So that's that one. It's a nice enclosure. Yeah, these things are crazy. Everything was pretty well protected, except for some of the stuff that's on the edge. Unfortunately, the quality of these circuit boards is such that there was a little bit of wrinkling of the traces, which is not a good thing. Oh, I see. Look, I can't plug them in wrong. I actually can't, I think. And I remember this one coming out second, the big complicated guy. So this one goes here. And be careful that this bracket doesn't knock off any of the stuff. But everything inside looked pretty clean. These look like they, in spite of their sordid past. Whoa, careful with that. Not to knock off any of the equipment with this bracket. Then this is the big guy. And there was nothing in here. There's probably an expansion that I could get. And this one goes over here. The one with the clock goes towards the brain. Make sure that's plugged in all the way. Are these plugged in? Yeah. Okay. And here's all the brains. This one's probably on the edge so that you could pluck off the controllers and program them. Yeah, servicing this thing, like if you had a transistor blow up, that would be pretty easy to fix. And even on early surface mount, that's easy to fix. It's just this latter generations where everything is so disposable that instead of servicing it, you're just replacing everything. You replace the whole board, so they don't really, the electronics get so small that you can't really get in there and replace one transistor. Wrinkle trace is not uncommon for boards made in the 70s and 80s. I have a few old IBMs, and all of them have horrible looking traces, but they still work. Yeah, it's just those traces can become a place where we belong. Doo-doo-doo, where the eagles fly on the mountain high. No, it becomes a place where there can be a crack. But for the most part, I mean, these look like they're wrinkled but not cracked. I think, you know, with some heat cycling, because these lived in a shed. They were in a shed. They saw all of the wonderful Pennsylvania heat variances. This state gets very hot and very cold to the degree where our roads actually end up freezing and thawing more than most other states, almost all other states. In fact, I think all other states. So our roads are naturally completely crap, which is why Pennsylvania gets a reputation for having terrible roads. It causes some pretty intense flexing to make them break. I mean, I guess I could trust them a little bit, but they've still got me. I'm shook. They got me slightly shook about the health of this device. Nobody wants to see a wrinkly crack. You know, actually, people are freaks, so I wouldn't say that. People are freaks. Oh yeah, this isn't going to get tight. This is just going to slip at a certain point. Yeah, right there. I got to watch for that. I guess that keeps me from over-tightening them, though. Of course, that also makes me roundify them. I don't want to roundinate all of my boltinators. This guy goes back here. So let's get this on the hand screw. I don't trust this thing to go in. Statistically, someone in chat. All right. We're going to leave that on a need-to-know basis. Bonk. There we go. This is just a ground lug. See, they've got this nice prickly washer on it in order to make sure that you get a good ground connection from it. And it looks like I can put all of these back in because this side door just presses into place. We didn't end up severing the front of the thing, so looks nervous. What's nervous about it? What are you saying? You're looking around nervous. Where'd that? Wait, why do I have an extra one? Oh no, I got 2 left. Okay, that's fine. That's fine. We're still good. We're still good. This thing was fascinating. I'm not about to start reverse engineering it though, because that's a huge undertaking that I'm just not going to do. Now, presumably this would still work, right? Unless there's some kind of a no, I don't think anything would go wrong except that battery. That battery is probably not all that great. Seeing as it's 40 years old. It's a light device. I do wish that it had a normal power supply so that I could just have this as a separate piece of equipment, because I would want this function, this arbitrary waveform generator, separated from everybody else. There is probably... That could have been a little gentler. There is probably a rack that you could, like a one-position rack that you could put this in that would enable it, but, you know, to a normal power supply. Or I could look at what these things actually output. But the electrolytic caps and the battery. I didn't see electrolytic caps, actually. Except for those ones on the power supply that were from East Germany. Are these different sizes? I got 2 different sizes here. I think the shallow ones went on the bottom. As long as there's no RIFAs in it. It'll probably just work. I don't think so. I think those caps were functional. I think they obviously weren't from Panasonic. Or were they from the early 90s? I think they're the late 90s, early 2000s. Good old plague of capacitors. The reason why electrical people like us get a lot of these cool old devices, because people have them and they explode. And they go, why is it turning off every now and then? And yeah, it's because you have weird capacitors. All right, so that's that side. Let me get these. It's kind of arbitrary about whether or not they have long screws. That's definitely the right one. RIFAs are those yellow translucent looking candy bar caps. Oh, those. Yes, yes, yes. They have a 100% chance of letting out the magic smoke once they hit about 30 to 40 years old. Wow. I used to see those all the time. Don't think I see them anymore. Those are used in power systems a lot, right? Yeah, I don't know if I've got anything that uses those. All right, so there were no big creatures inside of this thing. I expected to see more spiders. Maybe they all hatched when I brought this stuff inside. Line filters, I see. Yeah, we use X and Y caps now. X and Y caps are characterized by the way that they fail. They don't fail with a closed circuit, so you don't end up creating, a horrible situation when your caps give up the ghost. Man, I remember using these. I remember using these in labs at Drexel. I do. And they were new back then. No, they weren't new. They were pretty old back then, too. Reefers usually are X-class, I see. The plastic shell cracks, which allows air and moisture to leach into the cap, effectively creating a super low resistance in them. When you dump 120 volts into a capacitor that's effectively shorted, you get a nice smoke bomb. Yeah, that's enough to create heat. and heat being the enemy of electronics. All right, let's get the next device out. I'm going to put this one, I guess, back on the rails. Come on. It's not quite plugged in. Did I do something wrong? I don't think so. I think it just... Did I put the pegs on the wrong side? Yes, I did. Yes, I did. The pegs are supposed to go on the other side of the thing. Whoopsie daisy. Oh, really? That's the ones that smell like fish? Ugh. Whoopsie daisy. Yeah, but they don't care because 10 years is out of the service life, if anything. Oh, great. I made these a little too round. Now I can't undo them. Well, we can do it the old school way. This is the old... Oh, wait, no, I did loosen it. Never mind. Hold on. We're still in business. When the eagles cry on a mountain high. I get the dumbest songs stuck in my head when I'm streaming. Mostly due to like one little part of a phrase that I say. I'll say something and then I'll be like, my brain will just be like, remember this song? And I'm like, please don't. And then it just starts singing it endlessly. Please don't remember that right now, brain. Too late. I'm going to sing it all day. Remember that one Daft Punk song, Around the World? No, I forgot all the lyrics to that song. You guys know all the lyrics to Around the World? I don't. Now we can all share in the suffering. I really shouldn't. We do now. I know, that's why I love that song. I hate my brain. I hate it. I hate it. It can fuck off. Get out of my head. It's so old school Daft Punk, man. It's so good. It's so simple. What up, Lawn Dog? How you doing? Got our singular YouTuber. Jeez. Reefa. Oh, you're supposed to say it like reefer? Reefa. Do not remove brain from head. Why not? That's what drugs are for. Stupid muscle. Yeah, Willow and I did a lot of walks over the weekend. We did a walk around the whole neighborhood. Took her on a couple miles of walks. So she's actually kind of tired today from that. Being nice and quiet. I haven't heard her barking at stuff. Wait, you ended up on the garage floor? Would you go low? Or is it unrelated to that? Or were you just spacing out? Just having a hangout sesh? Long after that because I couldn't get up and I passed out. You gotta watch out for those lows, man. I keep something on you if you need to. If you're having lows like that, you might need to carry some glucose tablets around. Oh, I hate glucose tablets. You know, diabetic for like 40, not 40, 32 years. And boy, oh boy, those glucose tablets go. It tastes like orange. You love orange. No, it tastes like orange shock. It's like eating Tums. I mean, they're effective, but having all the equipment that I have means that I don't need to carry it around, support stuff like that. And then what they also do, they carry around a little tube of frosting. Delicious cake frosting. When sugar pills aren't a placebo, no, they're very useful, in fact. But I feel lows very strongly. The hypoglycemic is a very strong feeling for me. That's a crazy, waking up from a low like that is kind of existential. Flintstones vitamins, they taste like fruit. The fuck they do, they taste like chalk. Yeah. But for us, it was glucose tablets, and they've got that orange flavoring to them. Have you torn apart an Omnipod? Is there anything good in it? Nothing that you can use, but there is a lot of really cool stuff inside of the Omnipod, and we have, in the past, taken apart my Omnipods. I've got a whole new batch of them. I stopped saving them. I've filled a bin full of them, and I stopped saving them, which is probably bad. I need to keep saving them because they've got a microcontroller in here. I would love to give to some of you guys if you could make progress on kind of Arduinoizing it, because it is very similar to a sort of semi-related NXZT microcontroller. It's very similar to it, but there's also some extra like heavy-duty transistors built into the chip, and it's got Bluetooth and possibly, well, I don't know about Wi-Fi, but it has Bluetooth capability. So we could do a lot of cool stuff, and I could make my own microcontroller platform that exists solely built out of old Omnipod chips. I could move them from the Omnipod onto a little, a breakout or whatever, and sell them. I think that would be awesome. It's like, yeah, your microcontroller kept me alive for a couple days. But these are fascinating devices. There's a lot of what's called patient hostile design. There's a lot of one-way streets in this thing that don't allow you to reload these with insulin. They've got things that only work in one direction. It's crazy. Yeah, that doesn't sound like a good time. It sounds like a kind of a struggle. But yeah, I do want to make some progress on that. I just haven't had the chance to work with it at all. But there's a really nice microcontroller in these things, and I can do semi-assembly line disassembly of these things. The real way to do it, the cool way to do it, would be to tape them down to the CNC, if I had a CNC, and have it sort of trace around the outside in order to open them all up. I can do it with a hot knife too. I can just go over this with a hot knife and open it up. We tried to set up on the mill. I tried to set up a little cage of these things so that we could run it by and get the same cut over and over again, but that didn't really work. But yeah, ripping them apart is doable. Then getting the circuit boards out is doable. Then I can get all of the microcontrollers out of them. But then from there, we don't really have a good way to program it. And so I need some help getting into the core of the thing and then reverse engineering some way to put a bootloader on there. And then we'd be able to have a microcontroller platform made out of my old insulin pumps, which is a fairly steady supply, although at some point, probably going to be upgrading to the Omnipod 5. I don't know what the status of that is with the Android Auto Pancreas system. AAPS is what I use to coordinate that stuff. So if AAPS supports the Omnipod 5, there it goes, now it snaps in, now that I put the stuff in the right spot. 100% China's already doing that. I love looking at Chinese jank. You should order some cheap devices on AliExpress and take them aboard sometime. I got one of these Android powered translator pens. Oh, that's kind of neat. And they literally were cutting the PCBs out of old phones and running small jumper wires to a custom board to run it. What the fuck? Yeah, that does sound fascinating. That sounds absolutely... I should be looking a little bit more on AliExpress because we can find stuff that's easy to make fun of and take apart and have a good time doing that. Because that's what we used to do on Fridays on this show. We would take stuff apart and critique all the way. We could be the little shitheads that are critiquing your device and saying, you should have done a better job designing this. One of my favorite tricks, of course, is with the Torx security bits, where if you have that little nub in the middle of your Torx security bits, and by the way, I'm looking at a Torx kit that just intrinsically has the hole for the nub in the middle. Like, you can't get this in this doesn't fit somehow, in non-security bit fashion, but with the security bit with a little nub in the center, that little nub in the center actually gives you a third point of contact for a flathead screwdriver. And so if you just stick a flathead screwdriver in the security Torx bit, you can unscrew it. It's kind of amazingly low security for what it is. All right, so that, just a simple yank of the pin of the, jeez. And out comes the device. This is another little piece of stuff that might be usable. Keeping thousands of phones out of e-waste and repurposing it to save the unusable component. Yeah, that is actually pretty good, to give new life to something that would normally just be thrown away. That's sort of what I'd be thinking of doing with the insulin pumps, because it seems like kind of a big waste of technology. T-Slim, the company that made my old insulin pump, T:/Slim, that was close, is actually making a pod-style insulin pump that has a detachable control unit. So you're not constantly reusing or throwing out electronics. Not like they're, you know, especially rare or anything like that, but it's just nice to not contribute to e-waste. I've been fighting like mad with my Dexcom G6. I seem to have developed some kind of an allergy to the adhesive on the sensor clip. What? That sucks. I've been doing the Dexcom G6, G6, in my shoulder. That's been a pretty good place for it. It makes me feel like I've got a shoulder-mounted rocket launcher, like a mech. Targeting hostiles. Beep beep. But yeah, that's I've not had trouble with it. The old school insulin pump stuff, the Medtronic, used to use this adhesive that was horrible for me. It would continue to be adhesive after removing everything, and so it would pick up lint from shirts and stuff, and eventually I'd have to rub my skin really hard to get that stuff off. But I think they've changed their formulations. I don't know if Dexcom has changed theirs, but they've always been okay. They've kind of figured out the adhesive thing for the most part, and I at least don't have that kind of a reaction. Lives fine for about a day, and then it starts to itch like hell. That sounds like an allergy. Have you tried, what is that stuff called? There are various things, Opsite Flex Fix. Opsite Flex Fix is like what they put on before surgery, but it's just like a plastic layer that goes on top of the skin, and it's relatively thin. I actually use it on top of the Dexcom to hold it down. You could potentially just cut a square out of it, put that on your skin, and then apply the Dexcom to that. So the Dexcom will stick to this very thin plastic adhesive. You get a larger contact patch. You'd have to play with it to see whether or not it comes off in the shower. Yeah, like Tegaderm. Yeah, exactly like Tegaderm. That's Opsite Flex Fix. You'd have to see whether or not it peels off, though. That's the only problem, because I know it to peel off a little sooner than the Dexcom. But if you find one of those, you could potentially just put the Dexcom through that, and it would stick to that other stuff, and then you wouldn't have the allergy issue. It's such a weird workaround, though. Use what's called nano adhesive. You actually buy that stuff in the form of tape now, which is neat because it's reusable. Terrible for medical purposes. Well, no, but the stuff that they use for surgery is supposed to, stem the tide of bacteria from getting into the operation sites. Oh my God, there's a bunch of huge wires on the inside of this thing. This is a frequency counter. Universal counter / timer. So we got frequency A, period A, ratio, time, width, duration. All this stuff can be replaced by much smaller and more capable equipment, to be fair. But I don't know, there's some cool stuff in here. There's an auto or level adjustment, auto trigger level. Shaped out, and then trigger level, and then we've got our external. Are the inputs? Where's the output? I guess the output is just it counting. No, you would just install it normally, because the syringe would go through the plastic and your skin and leave behind the wire. It shouldn't affect the operation. You could leave a hole in the middle if you really want to, but I don't think it would be necessary because it's all sterile. And it's not like there's a big flap that it would create. It would just literally puncture a hole. So I think it would remain, because that's the whole purpose of that stuff, is to go down and stem the tide of bacteria from getting into open wounds that are created from surgical stuff. is at least my understanding of it, although, you know, I'm not a doctor, so none of my advice is medical in any way. I'm pretty sure I'm not a doctor. I've looked it up before, and I think I have the answer. May surprise you. Wouldn't that be cool if one day, and you're just because you start streaming like electronics, and then one day you go out to the mailbox and you're like, oh, I'm now a doctor. I got an honorary doctorate for my work in educating electronics. You can literally buy a frequency counter for $11 on AliExpress. God damn it. Yeah. I know, it's just like a display with like a microcontroller that's commonly available, but yet it is still more capable than this thing sitting in front of me that probably cost hundreds of dollars in its heyday. Yeah. Welcome to the... Man, that paper towel came back from the desk. Really nasty. Really quite nasty. Nasty, nasty. Nasty, nasty. Nicey nice. Let's roll us a giant. All right, let's get this out of the way. Out of the way. I need room to function. This is probably going to be fine with just hand screwdrivering. So, like its other... oh, well, look at this. Look, it's got a little lock in the back. So we just open this lock up, and then this whole panel comes out. It's kind of driving me nuts. The last time I had to take the sensor off after 3 days. That sucks because the Dexcom stuff, they're like, it lasts 10 days, you heathen, you absolute worm. And you're like, okay, Dexcom, I'm sorry, Dexcom. They're like, yeah, you unbelievable cretin, you nasty subhuman diabetic. This will last for exactly 10 days, and we will only prescribe you for that and nothing else. And you're like, oh, okay. Thank you for keeping me alive. So you only get the amount that'll last you until the next thing. It's fucking crazy, man. These things were thousands of dollars. Yeah, lab equipment made by a reputable brand calibrated to accuracy within whatever amount. And it's true. It's true. We only have a serial number, though. I don't think I have a certificate of accuracy. For IEEE 488 address selection, refer to instructions manual on the Inst ID button will display the current address. Jesus Christ. All this for a frequency counter, huh? A lot of damage. These look pristine. There's no wrinkling in the traces that I can really make out. Nice green circuit boards. Let's take a look at the other circuit board too. I'm doing this with minimal damage. I don't want to get too far into these and discover that I've actually broken it all. 10 grand area. You really think? Well, for the whole thing, man, there's a lot of 1970s university money that, oh no, those are fuses. Those aren't greeble caps or whatever the hell. Do we have anything that's going to explode on this? Instrumentation, those aren't potential. Yeah, oh, instrumentation potentiometers, side adjusts. And then we've got these clear thingamajigs all the way up here that we need to look at. Look at those. Got a nice matte silk screen on this thing with no, matte solder mask with no silk screen. Which is, I guess, just how they did it back then. Oh, and there's the address stuff. Speedy, this is something that I say much of the time. You're preaching to the choir, my friend. Yeah, this stuff, the calibration is what's so expensive on this. The fact that this is made in order to create more electronics and do electronics testing means that it has to be in a completely different category from your consumer devices. What's the model number? Model number here. this DC 5009, universal counter / timer. I don't really have a model number. Unless it's something deeper within. ISO temp. That's an interesting thing. Tech T1. 9170. It might be 1991. I don't know though. Oh, labeled start stop. What kind of controllers do we got in this thing? 8980, huh? Is that the Nintendo chip? That looks okay. What the heck are these? I guess that's a board edge connector. We're going from board to board. This seems to be just like something protecting it, maybe? I don't think it's like a programming interface. Drop like a huge connector on top of that. I don't think so. Oh yeah, it just goes to board standoffs for the layer below it. So this is just connecting to the standoff, the straight standoff underneath it. A 6502. At least on that side. I don't know, there might be something else over here. Oh no, this is all amplifiers and stuff. I mean, this is a digital counter, so... Yikes. Like, we have internal wire connections, which is kind of weird. It makes me not want to take this apart anymore, because I'll never know where to connect the blue wire again. These, I guess, are shielded, so they're not creating a whole bunch of interface by flying around on the board. What the hell? Look at this heatsink. What is that? It's got flying leads off of it, too. LM 341PS. LM341. And it's got this massive heatsink that goes all the way up here. Pretty cool. Oh, and then it connects to something in the front panel. I see. Is that ground? Oh, yeah, that's the ground for this connector right here. So this connector is being heated up by the LM341. What the heck? Bog standard. It could measure up to 135 megahertz. My God. The thing is, this is probably still pretty well calibrated. All things considered, this thing is probably still in very good shape for what it is, in spite of the fact that it sat in a unit in the university for 20 years. Hey, I could have even used this in some of my labs. This might be one that I used before Drexel moved their labs over and got probably much better equipment. They probably have very good equipment nowadays, to be honest. And it's probably all desktop equipment. It's probably, you know, this is probably a device that's this big, and it's just something that stands up on your desk like my oscilloscope. Cool look inside these things. I mean, these are little relay units, little clear relay units, which would make watching this thing operate probably that much cooler, because you probably turn these things on and they make all of those, the machine is thinking noises. You know, all those noises your computer used to make. Although it's not the hard drive in this case, this is all solid state, but it would be making all these clicks and chunks in order to calibrate itself. I like that system of locks, though. It means I don't have to undo all these. All right, let's put this thing back in. Now that it's cleaned up, front panel's already looking brand new. And that should just click into place. There we go. This one is the useless one. I don't think I'm going to get anything out of that. These are those connectors that Octoj loves. Hex key here. That's supposed to keep students from reconfiguring these things. Damn it. And then I just throw my wrench, my screwdriver. Just throw it. Just throw it. Throw it wherever. Doesn't matter. Okay. I mean, this is just a piece of plastic. It's really not doing all that much to keep it in there. From the 1981 Tektronix magazine, that unit sold for $1,299. Keep in mind, 1980, about $4,480 in today's money. Meanwhile, I got the DH0914 for $1,000, and it's like 10 times more capable than this thing. It's 1,000 times more capable. I don't know if I can put it to a specific number. Ground lug is not... Is the ground lug attached? I don't think it's attached to anything. So I think I can just yank on this guy. Yep, okay, there we go. These are relatively light for what they are. The aluminum cases are extensive, so that's nice. It was $0 when Father borrowed it from the lab one night. I picked this up in front of my friend's garage. And the statute of limitations is 10 years. So neither my friend nor I can be pressed under charges for these. I would desolder all those usable components for my component collection. What? Why? Why would you do that to this? These are still extraordinarily useful pieces of equipment, even in spite of the fact that they are extremely old technology and they're a lot larger than they should be, and I am kind of pinched for space in this lab. These things can easily live on a shelf where they harm nobody, and they help me one day. One day I'm gonna be lost looking for the magical lake. I'll be like, where did that magical lake go? It's almost like it's a magical lake and it doesn't want to be found. And this test equipment is going to be like, bother, you've saved us. You should look to the north. And I'm like, oh, the magical lake is north of here. Thank you, test equipment. I'm so glad that I didn't needlessly scrap you when you could provide me with some minor utility. And then I'll have found the magical lake. I don't know to what end. These don't have, I have not seen a single electrolytic capacitor in these, which is oddly prophetic of them. The ones that are closest to electrolytic were from West Germany. I don't know what kind of capacitors the West Germans were making, but there's another spider house. Spider house! Let's just use a toothbrush on it. Remember to brush your electronics. I am not going to go on these connectors. These are the ones that Octoj really likes, except these aren't the ones with the snaps on the sides, but they're those board edge, the direct board edge connectors. What's fun is we've got an active and an error light on each of these. That's kind of cool. We'll see what's going on inside of this, though. Instant ID. Huh, what? Weird. Weird, very weird. Various functions. I've got 2 units that have all different modules in them. Electrolytic caps can slightly change capacitance based on temperature. Not ideal in something that's built to be precision. That makes sense. Yeah, that does make sense. I didn't know that they were a big culprit for doing that, but I guess back then temperature compensating was very important. It wasn't intrinsically built into a lot of stuff. Like nowadays, you get TCXOs and you have voltage references and stuff like that. This is another one that I can take apart without soldering. That's nice. Or without doing screws, rather. Yeah, look at that. Beautiful. Look at all this stuff. Why is there so much stuff? Is that all just air handling? This is literally just a bunch of connectors that get you to the backplane of this device. Backplane being the place where all the data is running around. What the heck? It's a side connector. What am I doing with that? Neat. Big fuse. These would be the electrolytics. Are these West German? Can't believe we have capacitors from West Germany. If I were to scrap these and take all the usable devices off of them, then those West German capacitors would have to go into an enclosure. What's up, Bring Gigi? Yeah, there's a lot of interesting stuff inside of these, but these are big racks that are kind of bespoke lab equipment. These devices can probably only exist inside of the big rack, although, to be fair, there's probably an available, like, one singular unit thing that I could plug onto the back of this thing. I should probably open this up and look in the back, but what we have here is an arbitrary waveform generator, frequency counter, and what we're looking at is the I/O adapter that fits into that. Then we have a digital, a programmable power supply, digital multimeter, and some kind of a weird logic thing. I don't know exactly what. It's like an amplifier. It's like one singular op amp. But the more I look at these things, the more they're looking pretty clean. That is a lot of Wow. Anybody need some perf board? That's a lot of perf board. I guess these release from back here. Ow. Need a coin. So if you had a really good idea for some test and measurement equipment, you could probably build it on the prototyping board. I don't think so. These are looking to be in very good shape. I mean, they were stored okay. They were stored in a shed. Aside from the temperature swing of the shed, they probably weren't powered on for many, many years. The capacitors look to be in good shape. It's likely that I could possibly get away with powering them up. I'm feeling more, the more we look at them, I'm feeling more and more confident in that regard. I mean, like, here's an electrolytic capacitor on it, and it seems to be in perfect shape. Holy relay board, Batman. What the heck? Okay, that's one of them. Get the other two out. Third one is all breadboard. Yeah. Yeah, when you get down to those sensitivities, it's something you've got to consider. That's the whole engineering of test equipment. It's all very complicated. A lot of ones and zeros. Yeah, analog engineering gets to be complicated when you're dealing with such a system. Well, it does have a fan on it, but it gets slightly warm during operation, and now you're off by a lot. That's why you have $20,000 pieces of equipment that do some very simple testing. You're like, why? All it's doing is counting waveforms. I can do that on an oscilloscope. But it's like, can you do that with certified accuracy? Can you do that down to, like, the tiniest of time divisions? I thought these three things were going to be the same thing, but it turns out they are vastly different. This kind of hurts. Of course, it's been screwed in for 20 years, so 30, who knows how many years. Man, I'm smelling like really good food upstairs. I don't know if we're actually having that fish. So, space for prototyping. Why would you get it with space for prototyping, though? If you're getting it for students that are going to be gone in a couple years. Somebody was thinking on a weird frequency that day. This looks like power supply, but then we've got some stuff over here for communication for the GPIB and the power. But it's like, you got GPIB and power. What do we do with this thing? Okay, there's the 488, the IEEE 488 address setting. That down to 10 PS divisions with no more than plus minus 1 PS margin of error. I can't. You saw the circuit board that I designed. That thing's gonna have all kinds of crosstalk and super duper mega high speed applications. Things we're not doing here. This is actually for wire wrap. I see. Interesting. Well, that makes a little bit more sense. Except for these. I don't know what these are doing. They are jumpers, but they're just on arbitrary posts that aren't connected to anything. So, I mean, you could solder your way through this, but it looks like this is more designed for wire wrap because we've got a bunch of posts on this side. What I would possibly do with this instrument in whole or in part may be protected by one or more US or foreign patents or patent applications. Information provided. Requests by Tektronix Incorporated, P.O. Box 500, Beaverton, Oregon, Oregon 97077. Are they still in Beaverton? Should have thrown them a job application when I was there. Yeah, you got a bunch of 7400 series stuff on this, and two 6882s. MC6, or is it a B? Hold on. No, 6882 1P. Cool. I have absolutely no idea what I would ever do with this. I have no idea what I would ever do with it. But this one's mine now, so if I wanted to wire wrap a whole circuit in this area, I don't know how much room you have down here, because wire wrap can have posts that stick down pretty far, and I don't think they're going to give you a whole lot of clearance below this thing. Not to mention the fact that what the hell am I doing with all of this GPIO? What am I plugging it into? Is this for like telecom testing? 50M70 development card. I'm going to look that up. 50M70 development card. Tektronix. Programmable. Oh, it's the manual for $50. For only $50, you could unlock the secrets of... Oh, don't get me looking at Elvis mics again. I was looking at Shure 55 SHs. I was like, man, I could have the Elvis mic on my streaming setup. That would be kind of funny. Tektronix 50M70 development card. A development card allowing the user to implement custom I/O functions on an M15010 module, M15010. That would be this thing. That's what we're looking at right now. The very famous multifunction interface plugin for the TM5000 system. It accepts up to 3 50M series function cards. The MX5010 extender adds 3 more function card slots. The plugins include a 12-bit AD counter, 12-bit DA converter, 16-lane digital I/O, relay scanner, low-level relay scanner, Jesus Christ, I don't know what any of this stuff is, programmable memory, or a development card. So I have the development card. I have A to D. And I got the relay scanner. Oh my God, that's a lot of relays. That's a lot of relays for a relay scanner. What's a relay scanner? What the hell is a relay scanner? The fuck is a lobby? There's a lot of these relays on this relay scanner. A lot of flyback diodes, a lot of relays. What are they doing? I'm glad you asked. What the fuck do I do? What does it do? Do I hook up a bunch of relays to stuff that it actually, from what it sounds like, perhaps stuff like this is the origin of that brain scanning setup? Maybe I could implement the brain scanner on this. Oh my God, what happened to you? This is the worst. This toroid is in the worst shape that I've ever seen. That is just the most cursed toroid I think I've ever seen. This thing got dropped. Poor toroid. Who hurt you? I don't know if that would totally kill the functionality of this. Might still work all right. There'd be just some extra little fluxes hanging around. Is that a jumper? Yeah, it's seen slightly better days. You poor sintered bastard. There's a lot of relays here to scan with my 6821. How do you even... I don't even know the first thing about using these things, but it does sound like you could probably... What is that? Is that supposed to be there? Or is that... What is that? What's going on here? Oh, that's supposed to be connected here. This thing has been dropped. I don't think any of this is my damage to it. Well, while we're here, I might as well fix it. Rolls nice and easy. Up and over, and then I'll just place that back into its hole. Need to refresh the solder. The solder is old enough. So this is just a through-hole, I don't know if it's like a diode or something like that. It's some 2-pin device that, I don't know, it's like some square thing. You don't normally have square 2-pin devices on hardware like this, of this age, of this era. But here it is. But it looks like it ran into some mechanical issues and popped off where it was supposed to be installed. All I do, push it back through, and we're done. That's repaired. I don't want to bend these too much, because if I overbend these leads, they can fall off. They basically, the metal on them shears very quickly indeed. So that is, for most intents and purposes, fixed. Difference between the through-hole and the surface mount stuff, at least from the perspective that I used to have of through-hole and surface mount, was how it shreds off of the board during a high explosive, normal explosive event. There's part of this toroid is missing. I'm going to have to find another one like it, I guess, at some point. I don't know what purpose it's serving here. Stabilization of the power supply? Probably. I don't think it'll make a huge difference. I don't even know what a relay board does. Maybe we can read a little bit more about it. Hold on. Low-level relay scanner. Oh, it's just this. 10 pairs of guarded, normally open relay contacts with less than 1 microvolt of thermal offset in each channel. Each differential pair of contacts is accompanied by a third contact to switch the shield or guard connection. The 10 sets of relay contacts can be configured as 2 groups of 5 individual relays with 2 commons, or as 1 group of 10 individual relays with 1 common. Oh, God, this is just so dry. The desired relay switch pattern is configured by the internal jumpers. A tree relay can be included in the 1 of 10 configuration to reduce capacitive loading and potential noise problems. When using more than one 50M41 in a system, 2 handshake lines are provided. Man, they really make a lot of assumptions as to how much I know what the hell's going on. A lot of assumptions here. I don't know what the heck I would even do with this stuff. This is probably some really nice shit back in the day. From 1982 to question mark, huh? Multifunction interface system user guide. Man, that's crazy. Welcome to the M15010 Multifunction Interfacing System User's Guide. Copyright 1984. So this thing is not older than I am. It's getting close. Dear God. Function consists of the multifunction interface. Extender, presence, blah, blah, blah. Each houses up to 3 of the function cards in any combination. I don't have the connector for this thing, by the way, so I don't really have any way to interface with these. Communicates on the GPIB via the GPIB connector. So what would you use? Would you use LabVIEW in order to interface with this? Which means I could probably use Node-RED to interface with it. Is there a GPIB Node-RED? Of course not. Oh, shut up, AI. I have an application with a USB 6003 module. Okay, do we have to look everything up? So that would be a GPI, an $800. Oh my God, shut the hell up. An $800 like interface. I don't think that's not GPIB though. GPIO. And maybe that would work. Ah, okay. Well, whatever. Range of 0 to 30 addresses. Yeah, blah, blah, blah. That's GPIO. Self-test to power up during the self-test. Front panel indicates blah, 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 blah. Okay, so there's a... Oh, God. I could use that computer that I have in the back. That old 1980s, 70s computer, the command prompt one. I don't think I have any discs for it, though. I have to come up with like a memory card to disk adapter. Good Lord. I don't want to get too far into this stuff. What's that, Trey Pop? There's a lot of digital stuff going on here. I guess this is a way to coordinate your test routines and stuff and get into some pretty crazy stuff. It seems like with this device I could build that Muxt brain scanning device. Maybe that's where this originated. Where that originated, rather. You have to write code for everything. Memory card. There's a memory card for it. Wait, did we run across something like this before? In that electrical, like, line worker guy had a bunch of equipment that was like memory cards for stuff. I don't know if it was Tektronix, though. I don't think it was. That'd be crazy if I happen to have a memory card for the system that I know nothing about. But I guess I could do custom here. This can be A to D. So if I have A to D and I have the relay board, then I could make the non-invasive brain monitor, because I could use part of the relay board to turn on LEDs, and then I could have muxing switching to all of the different analog light sensors, and then have it read by the A to D. This one's the one that has a bunch of AMD chips on it. Look at those big logos. That's neat. Well, okay, I'm going to put this stuff back because I have no freaking clue what the hell's going on. This is a variable capacitor, by the way. You guys ever seen a variable capacitor? I used to have bins full of these things. I shouldn't have gotten rid of them. A variable capacitor varies the capacitance by exposing plates to each other. So as you move this back and forth, or, you know, twist it on that platen, it will expose more or less of the plates to each other, changing the capacitance. Hey, Smith Clay, did I miss you populating your audio board? No, I'm still waiting for the PCBs in the mail. It's I ordered the PCBs, so version 0, not even version 1, it's version 0, should be getting here in weeks, months, maybe in the early next month. It's going to be a couple weeks for it to be processed because it is the Chinese New Year. No, they got approved. That just means that they're going to be building them soon. You know, the batch process has to go through, which normally does not take that long. I had to get them in the one in green, so that should get here sooner because I got it in green. But it still is going to take a little bit. So once it gets here, we'll have some nice assembly streams that we can do. But until then, yeah, it was just sort of a basic update that I am moving forward with those projects. It's just you guys aren't going to see a whole lot at the mo. All right, so back in these go, into this system, this ancient, interesting system that I suppose can lead to a lot of like customization of projects and stuff. You can do a lot of cool, whatever. I don't even know, man. You could do a test setup that sort of tests, I guess, tests your product. Why did that feel really bad? God, my dog is desperate out there. She's barking up a storm. Wow, that really stuck. What happened there? Cards look okay. Maybe I'll put this one in first. It should have, the toroid should have enough clearance. Yeah, it's got plenty of clearance. It's just kind of misaligned down there. Oh yeah, look at that. It's very misaligned. It's not upside down. Not this one. Turns out these are shit. I think they're bent very specifically to the one that they were in. Probably because this thing has been dropped. Wow, it really sticks in there. You get an email when they ship them? Yeah, I assumed as much. Oh, I see. It's the screw post. You're supposed to screw them in from the very beginning, and it'll slowly walk it in. I see now. I see now. That's what was sticking, is the threads were partially engaging, and then when I went to pull it back out, I'm fighting the threads. I don't think I did any harm, but I could have. It hits those threads first instead of the electrical connection, which I guess makes sense. I don't want it to break. Man, this is tedious. Need like a giant screwdriver to do this. What the? Just shifted and scared me. Well, that's an interesting and probably pretty expensive at the time bespoke hardware device that I'm sure somebody thought that they would be using for something, but for the life of me, I wouldn't be able to figure out what to do with something like this. Could you imagine? Yeah, they don't want you jamming the card in. Yeah. Yeah, it mitigates all kinds of damage when you have the strong metal thing be the sort of initial interfacing thing. But yeah, I do not know what I would do with something like this. Pretty old stuff, too. It's nice old school stuff. You know, the D to A, the A to D, I don't really need. I have better stuff for that. Was I tightening the wrong one? So, like, I could continue to screw that in until this is flush. And that's probably what you're supposed to do. It just feels a little tight. Yeah, good enough. God, I'm smelling onions. Not onions and garlic, just onions. Okay, and then, you know, they give you knurled marking. The screws are knurled so you can do them by hand, but I wouldn't want to. Components just super specialized and outdated. Little practical use in any modern lab. In a modern lab, hell no. You don't need that kind of, you know, your computer interface is so much easier nowadays. But I mean, in the 90s, in the 80s especially, but in the 90s, this would be pretty cool. Pretty powerful thing to use. But it would be kind of fun to resurrect some kind of an old system with this. Like, put together chat, somehow get chat onto the screen of the old computer. That would be doable without this device. We wouldn't need that. But that would be the kind of thing that would run this, is that kind of old school, you know, couple lines of code sort of thing. There we go. This makes it much easier. Oh, super extra torque. Now everything is flush in the front of this. Jeez, this would make quite a lab setup. Start looking like Serial Experiments Lane. Hooking all this shit up to the computer. You plugged it into the wall, Dade. You could literally get any terminal computer, emulate the terminal server on a Pi, and inject anything you wanted into that to be printed on the terminal. I know, I've done Python where I'm using the I/O of the Raspberry Pi. And it was hilariously easy and cromulent and simple. What I did wrong. What did I do? What did I do? I did everything right. I finally had time. There you go. And I could get chat on a Raspberry Pi in like 5 minutes. It would be inside of 5 minutes. I would have chat on Raspberry Pi, and I'd be able to make it react to stuff. I don't need all this to make anything like that go down. And there's no real sense of nostalgia for this equipment. Maybe some of y'all have it. I don't really have it. Look at the size of this thing that it goes into, though. And this is not that big of a piece of equipment. It's literally like half of this thing is used up by these. The hell's the other half doing? Urgh! Good God! There's probably a giant transformer in this, and not the cool kind. There is a giant AC fan in the back of this thing. Huge inputs. Huge tracts of land. Look at the size of this thing. And it's gold. It's all gold connectors. What the hell? Yeah, much less space. Isn't 80s and proprietary. Blah, 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 blah. Still, if I need a frequency counter, I got one right here. Smells like a shed. And it looks like one, too. Covered in dirt. Like horse dirt. Ooh, that's some nasty shit coming off of that. Holy crap. Wonder how much asbestos is in this thing. You know, some people like restoring old school stuff like this. I don't think I'm in that category. Although I am somehow on that list in Blue Sky of old computer stuff. I don't really get that nostalgic kick from this. I like keeping it a little bit more new school. Nasty. Nasty, nasty. Nasty, nasty. This side is probably cleaner. Yeah, that's a little bit cleaner under there. Well, it probably does need a good wipe off. Of course, this thing is designed to go into a telecom rack, and if it's the right kind, it'll snap in. But holy crap on a stick. Just a lot of stuff here. I'm reluctant to plug this thing into the wall. I don't think I really want to do that right now. I don't have a plug to plug it in right now either. Is there one over there? Looking over there. I don't see one, although I do normally have one over there. Maybe we can take a look and I can just power it up and see if it blows up. Give me an 80s terminal? Hell yeah, I'll restore it. Some highly outdated piece of test equipment that pretty much nobody will be interested in. Whatever. Yeah, I suppose so, but there's a certain nostalgia to this. And especially you can plug this thing into a terminal. You can use it with your old 80s terminal. Maybe not so appealing, but this stuff is less available for the general consumer market. I don't know if you can jump on like a flea market and buy a bunch of these things. I don't have a power connector for this thing, so we'll have to power it up some other time. In which case, I'm kind of out of stuff to do because I really don't want to take apart the back end of this thing. I don't know how many giant capacitors are in here. There's a screw in the 120 volt indicator. It's an actual screw inside the panel on a list of the different voltages. It has all the different voltages that this thing could take in, but there is a physical screw in that, and then these are holes in the panel. Is that just to indicate, or does that actually do something on the other end? It might just be to indicate what voltage it's on, and it's on 120. That's very interesting that it has a physical screw in the back. It's like, we're going to be definitive about this. There's no questioning what power this thing is designed for. That's kind of wild. And this is the GPIB connector down here. This thing is some kind of a specialized one, and it's all gold. It's all gold, the whole thing. You could, but why would you want to just use modern equipment? Well, you know, if you have a certain nostalgia for a lab aesthetic from back in the day, or if you don't want to buy a frequency counter, like yours truly. I don't want to buy an arbitrary waveform generator. I already have, well, I've got the one I guess I could buy another one of those, but those are like $75, and this was free. Where's a power plug? I've got to have one around here somewhere. I know I've got plenty of NEMA connectors for all kinds of stuff. Maybe in the kick bin? The wire kick bin. Come on, wire kick bin. No, not in the wire kick bin. I've got replacement 120 volt fans for this thing, but no NEMA connectors. They're all in the wire thing that's in the other room. So I don't think I'm going to be powering this thing on. Maybe not today. Maybe we'll save that for another day. Maybe we can clean up the other one and take a look at the stuff at some point in the near future. And it would be really cool to have all this stuff on the blinking lights wall someday. So it's probably going to go back into storage for a couple years until I move spaces and I don't have any current ambitions or I don't deign to be moving labs anytime soon. But if I do move labs, I would very much like to have an equipment wall. And so it seems like I would need to have the full space for 2 of these things on the equipment wall. And then we can hook everything up and get it all functioning with each other, possibly with GPIB, maybe not, and have the ability to have just different displays of blinking lights in the background of streams. So when I do a BRB, I could put on music and I could put the camera onto the equipment wall and it would do all of its flashy things to the music. I think that would be kind of neat. This is not an equipment wall, that is a machining space, so significantly fewer blinking lights. When you get over here, that's where all the blinking lights should be, but they're not. My audio interface hookup wasn't as flashy as I would have liked it to be. There's at least the one piece that's flashing with my voice. But yeah, this, I don't know. I have ambitions, but I don't know how long it'll take to get to them. So I think that's it for me for now. We're waiting on circuit boards, so we're kind of doing some other stuff. I will be getting back to Burn the Subs for sure. Maybe we hit that this week. If I run out of stuff, I got to do some soul searching for Friday's stream. We'll keep it interesting, though. I've got a whole nother one of these racks to look at, but we kind of already know what we're getting into there. It's going to be the same exact vintage of relatively clean-looking electronics and, you know, West German capacitors. We have a 60s precision drill press. If we would want to replace it, we'd have to spend 6 to 7 figure values and still aren't able to reach its precision. It's crazy. That's why I still use old machines and use punch stripes to program it. Punch stripes, that's kind of amazing. Yeah, the vintage stuff, what is it about that stuff? I mean, they were going like, material costs are not as much, shipping costs are not as much. We're not trying to nickel and dime absolutely everything out of the consumer in this case. So you have nice, heavy equipment. It's been built with real metal, and it's got a lot of inertia behind all of the components so that you can reach a high level of precision without stuff going awry. This thing is powdered sintered metal for the most part, and it's small, and it's got only a certain size of motor on it, and the screw drives are a little bit cheap, and everything, you know, it's kind of it's got a relative level of precision to it that can't reach anywhere near something built for like World War II standards. Although, to be fair, there are classes of equipment that do reach that level. You have to pay for it. So, you know, I got my $1,500 out of this thing. We modified it a lot. Now, at one point, we do have to pull this thing apart and get all the old grease out of it, re-grease it, put it all back together, and I would love to CNC it at some point too, but that's not for today. That's not for this stream. But yeah, this old test equipment is sort of a little bit completely outdated. There's not much hope for me using these sort of in a relevant manner, you know, with modern electronics testing and stuff that we do here. I don't know. We'll figure it out. I mean, I'll have these things in the background, so if there ever is a need for them, I can lug their 60-pound asses in here and use them. The main bonus, the cast iron doesn't move anymore. New cast iron lives, and everything has to be reground and re-scraped constantly. Damn. I've seen a lot of it. So I've been watching a lot of the Australian machine shop channels, and they've been doing a lot of stuff with lapping, where you sort of ascertain whether or not the thing is flat with some indicator fluid, and then you sort of you scrape little tiny bits off of it until everything is sort of relatively level. And apparently that's a big deal with these guys. But all these guys are getting this equipment secondhand and then discovering, you know, oh, well, my old machine needs this improved and this improved and this improved, and they're sort of DIYing their way into sort of higher levels of precision. But I guess if you get something that's good enough from a long time ago, it might have all been settled. But then again, if you move it into your machine shop, you're going to deal with, you know, the legs not necessarily being on a flat surface on a microscopic level. And so that'll end up causing flexure and movement and stuff. So chasing precision is not something that I often do. When you build a circuit board, when you design a circuit board, you do it in CAD, you send it off to a board house and they build it to their level of precision that you've put inside of your CAD program. You don't have to worry about a lot of that stuff because the levels of precision for like photo printing, for making circuit boards and electroplating and all that stuff, all that level of precision stuff is like just far and away anything that you're going to reach with like machine shop stuff. With machine shop stuff like this thing here, I'm like, my hole is probably going to be close to where it should be, but not really. I'll probably have to take a file and make the hole into an oval in order to fit a bolt through. That's generally what I deal with this thing. With electronics, I'm like, this thing is going to be within 0.0001 of a millimeter. There's no way that anything is going to be off at all. It's crazy. It's crazy the difference in sort of precision that you have to kind of consider. Cast iron has internal stresses which release over time with vibration, and it warps the machine. Neat. I did not know that. You have highly specific instances where you need it. I'm sure if you had the money, you would have, oh yeah, modernize the equipment. There's always going to be someone who needs some specific piece of equipment. That's, I mean, for the most part, for us, it's like chasing the glorious imperial dollar. We don't have the big bucks to buy a modern Bridgeport that's going to do everything that the World War II machine did. Instead, if we're going to look for machines, we can either buy the cheap one that's warped or the old one that somebody's trying to get rid of that is actually pretty good because it's old. That's sort of what we deal with. But if we had the money, definitely buy a $40,000 machine and it would do exactly the same, if not more, than the old stuff, because there's a reason a lot of that stuff gets replaced. But yeah, for us, it's all the bullshit tier of everything. So, and with that, I'm done streaming for the day. I don't have anything else to do. I don't want to draw out my streams to be kind of useless. We looked at these devices and they look pristine inside. They look very good inside. There are wrinkled traces which are characteristic of this era of electronics. Little bits of moisture from the air get in and they get under the solder mask and they end up making your traces kind of wrinkle. It's an insidious problem because if you try to scrape it, you can completely damage the trace and then you'd have to run like a wire on top of it or something of that nature in order to repair. It can also cause cracks that are in the exposed parts of the solder mask, like right between the exposed and the covered part, you would get a micro crack straight down that. I don't know if there are any instances of that on these. They look like they were in really good shape. They've been kept moderately out of the environment. They haven't been exposed to excessive moisture. They just have ambient air moisture and dryness and, you know, repetitious temperature stuff over time. And so there's a possibility that when I turn this thing on, there's a spark show and I get a bunch of blown up capacitors, but the capacitors look pristine. They look like there's no damage to them, there's no bulging, there's no issues. So I might just power this stuff on and it might work perfectly. We're not talking about capacitor plague era caps. This is pre-capacitor plague era. This is pre-unification of Germany. Got West German capacitors inside of the one thing. But anyway, we'll save turning them on for another day when I'm a bit more brave. Maybe when it's not so cold out so that I could possibly open a window if there's a little fire. That's kind of the consideration that I have going into this thing. I'm not Uo's lab. I can't have constant explosions and fires on my desk. Because I live in this house, you know? Anyway, we're going to get into some new stuff this week. Well, new old stuff, maybe Burn the Subs. We could take a look at that, and I could try to get Burn the Subs running on Node-RED. For now, I'm going to test that the light bulb turns off when I stop stream. I will catch you guys later. On Twitch right now, is anyone else doing thing? Do thing, be Twitch on Twitch. Channel name, twitch.tv, oh bother. And then I can check to see everybody's online except for the people who I would raid. Paleontologizing isn't even on. Donad's not on. Davies isn't even on. Boom is not on. Oh, everybody's playing Vintage Story. What's Sir Lawrence doing? Fantasia. All right, it is not the, Ghost Freak is playing Tarkov and stuff. Here's the end card, by the way, if you guys want to check out my Discord. I, of course, have a Discord, because you can't not have one these days. But I've got one. Oh, wait, that's end card. And my next stream is in 1 day, 20 hours, 37 minutes, 50 plus seconds. It keeps going up. Or no, it goes down, doesn't it? 48, 47, 46. Anyway, yeah, I'll be back in about that much time. And we'll do something cool on Thursday. Wednesday, I don't stream in case I need to order parts. And I don't think I need to order parts today. I am just simply going to sign off, and I will see you guys later. Take care.